Hello my friends, I'm Google Voice. I'm taking courses to have better pronunciation.
Well, thank you, music. Right on. Okay. Hello. Welcome to the stream. Welcome, welcome, welcome. Hello, hello, hello. So today is what? Today is what? I don't remember. Today is probably Friday. Right. Today is probably Friday. That means today, according to the schedule, we are doing a random one-off stream. Hello, hello, everybody. Right. So today is Friday. So yeah, I think I saw a resubscription. Thank you, Colin Betko, for 10 months of tier 1 subscription. Thank you, thank you, thank you. Really appreciate it. 10 months, almost a year, by the way, almost a year. So yeah, today is Friday, and that means we're doing a random one-off stream. And the topic of today's stream is going to be Webgl. That's right. So we're not having any particular goal for today. So today I just want to explore Webgl as a technology, right? So I just want to explore Webgl as a technology and just go through some tutorials, maybe on MDN, or not MSDN. MSDN is a Microsoft thing, like MDN thing. I remember that like there was a couple of tutorials there and stuff like that. Game of Life and Webgl would be actually pretty interesting. So the way I actually wanted it to do for Automator, right? So essentially you encode the state of the board in a texture, you put the texture into a shader, and basically with a fragment shader you compute the next texture based on the previous one, right? So as far as I know, you can access the texture in the fragment shader through samplers, like sample2D type. And the thing about OpenGL, at least, is that it interpolates everything, right? So basically you can access between the pixels of a texture, and OpenGL automatically, I'm not really sure if OpenGL or like GPU, so something interpolates between the colors of the texture. So I think one of the ways to combat that is probably would be to disable interpolation, right? So setting like some sort of like interpolate, like I don't know. There's a way to disable that, so there's like a very specific edge between the pixels, and yeah, I'm not sure if any of that makes sense because I'm not really good at OpenGL. But we're gonna, yeah, it's called nearest, yeah. So basically you disable interpolation, you do nearest, and that will enable you with actually seeing the borders between the cells or something like that. Not sure if all of that makes sense, but anyway. So, but first, before we go into actually coding like cellular automata in shaders and stuff like that, we need to learn how to fucking use the shaders, right? So we need to learn how to use them. So before we're gonna start doing all of that, I need to pour a cup of tea. How everyone is doing? Hello everyone. Hello Rain above Milan, Kostik, Ayguduk, and both. Sorry, Mon. Hello, hello Lord Virdoza. Welcome, welcome, welcome. So, close trouser down. Alrighty. It's kind of interesting. My French pistol not always. It's kind of weird. The sieve in a French piston actually does not, like, over time has a problem passing the liquid through. Maybe I should actually finally clean it or something. Anyway, so let's find some tutorials on the how is it called, Webgl, right? Webgl. Yeah, it's Earl Grey. Webgl. So I think I saw some tutorials on MDN. Yeah, Webgl 2D and 3D graphics for the web. Oh my god! Oh my god, chat. Webgl is a JavaScript API for rendering high-performance interactive, blah blah blah, blah blah blah. So there's examples. There's also Webgl 2 guides, tutorials. Okay, so I found a Webgl tutorial. So maybe we're gonna actually. Why? What did you done? What have you? Why did you mention that? Holy shit! Hello, by the way, welcome to the stream. I have shit to do. I can't be singing all the time. Okay. So getting started with Webgl. So we're doing Webgl. You see, I'm learning web technologies. So soon I'm gonna become an epic web developer. I'm sorry. So yeah. So we need to create the body and the canvas and shit like that. Okay. Stop. Get some help. Alright, so how are we gonna call the project of like Webgl? I don't know, your mom GL. No, so there should be something. I had a recently pretty interesting. I posted a recently interesting idea on the Discord on generating names. Yeah, basically. So essentially, I've got a list of consonant letters, right? So consonant letters. So let's create something like a name generator, right? So it's going to be name generator and site.e generate Py. We're going to use Python for this one because Python is a good language. Python is in fact a good language. So here are all of the consonant sounds, and I'm gonna put them, all of them here. Oh shit, Python is actually not properly highlighted. Holy shit. Yeah, oh my god. How do I properly highlight Python? So no light theme. I can probably enable the light theme because I recently started to develop my own theme. But it's not full. It only works for C-like languages. Like, for example, it works for C, as you can see. I can probably do something like that. Oh, by the way, so site.e has abbreviations. You can easily create your own abbreviation like this. argc-char argv, right? So then you can do new line, then new line yet again, then tab, then you can say that you want to put a cursor here, then new line again, and then like this. You can save that and it's automatically available. There we go. Yes, I just did that. I just added abbreviation and I expanded it instantly. So this is a site.e. Guys, I'm telling you, I discovered a fucking gold. Seriously. This text editor is so underrated. Nobody knows about it. Like almost no one knows about it. And it's just like you can quickly do all of these such things and it's just so cool. Like, oh my god. Small break abbreviation. When what can we do right now, I think? So we can do something like SB. But unfortunately, it is not as powerful as snippet, right? It's not as powerful as snippet, but it's just like a very simple expansion mechanism, right? It's gonna be small break, small, new line, break. So 1, 2. So it's 1, 2. Let's actually add 3. New line. So we're gonna put cursor here. Minutes. I'm gonna save all of that and SB. Yeah, there we go, and then I can say 3 minutes. There we go. So, unfortunately, site.e suffers from the same problem as Genie, is that like when you try to zoom in, it's limited on how much you can zoom in. But I think we can fix that as well at some point. But yeah, so you can have abbreviations, and this abbreviation file is located somewhere in a home folder. Yeah, it's pretty convenient. So essentially, right now my theme looks like this, right? Hello world comment, right? But it only works well with C, C++ languages or C-like languages. By the way, from the point of view of site.e, JavaScript is a C-like language, so it reuses the CPP styles. All right, so okay. So what do we got? So I wonder how we can extend the Python, because for example keywords in Python are shit. So unfortunately, let me try to find the Python file Here is the Python file. Do we have a keywords? Keyword. Extra keywords. So I need to find the styles. Keywords path. Keyword. Okay, so the keyword for the Python is actually this style. So if I put it somewhere here, so where should I put it? I'm gonna put it somewhere here. So it's gonna be Python, and what I'm gonna use for the keyword, I'm gonna use color keyword. I'm gonna reuse the color keyword, and I'm gonna just put this entire thing like that. And I think the best way to do that is this. And if I save it now, it works. Okay, so now it does support keywords properly. Right, so yeah, you can just look for the properties in the corresponding property files, and you can add them to your user configuration and basically override them. So it's really a strange configuration mechanism, but it kind of works, and it's really strange. But anyway, so I want to replace this thing with nothing, and I'm gonna just replace all. There we go. So can your Emacs do that? I don't think so. Emacs cannot do shit. And by the way, so strings are fucked up yet again. So I need to find the strings. So there is a single quoted string. So maybe this is exactly what I want to do. So there's just strings, and then there is a single quoted strings. So this one is a keyword, and then string. So what was that? Was it a single quoted string? It was just a string. So I'm gonna use it like this. So it's gonna be simply color string. Is it strings? I think it's just strings. And yeah, there we go. String now is correct. So now I can say that this is a consonant, right? So this is a consonant, and I need also to take the vowels, vowel letters. There we go. So I'm gonna actually extend the style as I go, right? So I program in something, some phrases, some particular styles don't really work correctly, so I'm gonna just extend all of that. Vowel letters are these things, so let's actually put them here, and I'm gonna replace this stuff one more time. There we go. Can your Emacs do that? I don't think so. Your Emacs is shit. Okay, so what I need to do, I need to import random, right? So importing random. So this looks like shit, but maybe that's okay. So and essentially we want to generate a name with n syllables, right? So let's do something like generate name. Holy shit, that looks scuffed as fuck. It's gonna be n equal, let's say it's gonna be 3. So it's gonna be 3, and we're gonna be just iterating in a range of n. And I think I'm gonna assume that I'm using Python what? Python 3, right? I'm using Python 3. So I remember that in Python, I can probably check it out like quite easily. So it's Python 3, import random, and if I take a look at the random in here, so I do remember there was some sort of a thing called choice. Yeah, there was a choice. And if I take a look at the random choice, right, here's a random choice. So basically you can provide a sequence and it chooses a random thing from that specific sequence. So essentially if you have something like this, right, so you put it here and you can do random choice CS, it gives you like a random letter from that thing. So that's pretty pogue. And now what I can do, I can prepare the result, right? I can prepare the result, and the result is going to be plus CS random choice, right? So I think I can also duplicate the characters, like yeah. So I can also duplicate this thing, and there we go. And I can just return this entire thing. So there we go. We have a random, like simple generator, generate name, and there we go. Might as well actually wrap it if name equal main, right? If equal main, then just do it like that. There we go. It's pretty pop. Now list comprehension. List comprehension would be actually quite interesting to implement. Let's give it a try. So essentially we're going to be iterating like for I in a range of n, and for each of this thing, yeah, this one is interesting because you have to like have two of them. For x in another list where you have a random choice CS, random choice VS. And what's interesting is that then you say that I yield X, but that will give you a list instead of a string, right? That will give you a list instead of a string. So how do you convert a list of characters into a string? I think you join everything, right? So if you have something like A, B, right, then you can do something like this, join, if I'm not mistaken, yeah, and then you can even separate things by a particular, yeah, so you basically join everything, which is less readable than this code, actually. So the next thing you do is just join, alright, and what the fuck is this? Like seriously, come on, like doing these functional declarative things just for the sake of these functional declarative things quite often just doesn't make sense. Like, I mean, this is more readable, in my opinion. But again, readability is actually a very subjective thing. So do you find it readable personally? It's just, I don't know. I don't think it's a good idea generally, especially for such a simple things. So whatever. All right. So let me do the following thing. Maybe I want to actually also put bin sh. So we have a comment thing. No, not bin sh. User bin environment Python 3. Right. So I keep forgetting that I need to use Python 3 in 2021. Right. And now if I do name generator chmod plus actually it has to be like this. Generate, and then I run generate it. It actually didn't give me the name because I forgot to print the name, right? So I forgot to do this thing, just print. There we go. Bseva, is that a good name? So yeah, now this entire thing generates like random names. So we have Bseva, Yebuyu, Ditole, Ditole. This looks actually kind of cool. Bseva actually sounds pretty cool. Bseva. Yeah, I like Bseva. Yes, or Bsev. I don't know how to pronounce that, but Bseva sounds pretty cool. Yeah, so we're gonna call it Bseva. Does anyone need this script, by the way? I can upload it to Gist if you guys need it. Alright, so generate pi, and it's just gonna be something like this, so you can adapt it however you want. So it's gonna be public gist. Create a repo. I mean, come on, it's such a simple script. It's a very simple script. Bseva generator. I cannot post it, by the way. Thank you, Twitch. Very cool. So I need to restart Shaterino. And only then, probably, I'll be able to post a link. No license. It's a public domain, you can do whatever the fuck you want with it. Twitch. Yes, it is with something with Twitch, specifically with the WebSocket API of IRC. Sometimes it kind of like it stops like receiving shit if you don't reconnect. What is the font in Site? It's a Victor Monov. It's a K Comrade font. Victor Monov. That's right. Oh, and above. So you were asking about this italic thingy. I managed to actually make it work. Okay, so basically here it is. Look, boom, it works. So now you can have comments in this kind of italic, and it actually works in here. It's just fucking amazing. Holy shit. But it's unreadable completely. I cannot read that. So it actually really hurts my brain, especially if you have a code, right, and then you comment out some particular code like this. Like, Sometimes I need to read the code within the comment, and I cannot understand unless I uncomment it. It's just like really, really painful. But I can keep it for a while for the stream. Why not? Sure. So I can keep it like that. Looks cool and disgusting this time. Exactly. That's exactly my thought. It's cool and disgusting. Oh, holy shit! It also affects the string literals. Oh my god. Ooh. Okay. Am I gonna survive to this stream? Probably not. Biseva. Okay, so the project is called Biseva. Biseva. Whatever that's supposed to mean. Hopefully it's not something offensive. Because if it's something offensive, I have nothing to do with that specific word. It was randomly generated by a Python. Please sue the inventor of the Python RNG, not me. Okay? So 2021 is pretty dangerous year, I know. Like, I hope I didn't offend anyone. Anyway. I use it for short things, not for whole comment and strings. This is too much. Yeah, it is really too much. It is really too much. Semi-connected cursor static. Though it looks kind of cool. Not gonna lie. Like, the contrast is actually just... The contrast between the, you know, monospace thingy and the italic thingy is actually kind of cool. Anyway, so what were we doing? We were trying to create the thing. So let's go. Ooh, index HTML. So we need to do doc type. Nice one. So site actually fell into the same trap as Emacs with shit ton of different styles for different languages instead of having like a standardized set of the colors. So classic shit, am I right? So okay, so we're gonna have a user, and let me find the language. Do we have HTML, or is it called XML? I think it should be called HTML. So there's a hypertext F12. What? This is no. Oh my god. Okay. Language, user options, then edit properties. Yeah, we do have HTML. Okay. So doc type. Do you have a doc type? Doc type. So, and what we have here, we have keyword 6. Import PHP functions. So SGML keywords and stuff like that. So it's a keyword 6. Keywords 6. So we can have 3, 6, 5. Okay, this one is interesting actually. Because I do have them. I wonder if I duplicate these things several times. So I'm gonna put it here, and I'm gonna put this thing here, and I'm gonna keep duplicating this entire shit. So it's gonna be 4, 5, 6, and how many of them did I have there? I had exactly 6 of them. So it's gonna be 4, 5, and 6. And is it gonna affect? Yes. It did something, but I'm not sure what exactly it did. So what is this color, by the way? What is this color? It is pink color, exactly. Okay. All right. So at least it's something. At least it's something. Language. Okay. So we're gonna have a HTML. /HTML. Maybe it would make sense for me to also introduce abbreviations, if you know what I mean. Write something like, can I have, so here is, so we're gonna have a separate thing called HTML in here. So I'm gonna have shit ton of abbreviations for HTML. Unfortunately, I cannot have the abstract ones called tag, so I have to introduce something like HTML, which is HTML /n/t. Oh, this one is use a stab, but I'm not sure if it's a generally good idea. So we're gonna put this thing here, /n, and then /HTML. I wonder if that will work, and can I do something like this? Oh yeah, it works. Nice, nice, nice. So then the next thing I want to do, I want to copy paste this a couple of times. I might as well actually do the phone thing where I just duplicate this entire stuff, and then I just simply replace HTML with body, for example, right? So then I replace a couple of times, and that was really weird. So why I duplicated this entire thing, I don't know why, but yeah. So now I can do something like body, and body was successfully created. And also I need to introduce the head, right? So I need to introduce the head. So I'm gonna select this entire thing one more time. So, and what I'm trying to replace here is I'm trying to replace body with head. Yes. Replace, and that means I'll have to do a head in here as well. Alright, so I'm gonna put the head here, and let me do that one more time. So this is gonna be head. There we go. So not always super convenient, but I think I can get gist of it at some point. So Biseva, right? So we're gonna call it Biseva, and here we're gonna introduce the canvas, right? The canvas. I don't really like these tags, so I think I'm gonna try to find the where we use the tags. JavaScript, Python. Okay, tag. So where's the style for the tags? Okay, so here is the style for the tags. So it's literally called style hypertext. Oh, you can literally, yeah, replace them. So let me quickly do that. So where is HTML? Where is my HTML? So this is Python, and I'm gonna put HTML here. HTML is gonna be tags, and I'm gonna replace this entire thing, I suppose, with just colors keyword. Just keyword, and see what's gonna happen. And it didn't do anything at all. Thank you very much. All right. Canvas. So okay, let's actually go to the tutorial and try to follow that tutorial. So getting started, right? So it's gonna be canvas with a particular ID. So ID is gonna be equal to GL canvas, right? So this is a GL canvas. So width and height is gonna be 640. I'm pretty sure I'm gonna fuck up the sizes of this of the canvas yet again, because I remember I had problems in my previous game. So, and I already forgot how to properly handle canvases anyway, so it's gonna be a huge problem. Okay, so if I try to open this this page, let's see what's gonna happen. Let's see what's gonna happen. Let's see what's gonna happen. So game is not defined. Excuse me. Game is not defined. Oh yeah, it's basically watch condition from the previous thing. It's a watch condition from the previous thing. All right, right. So we successfully created the tag. We successfully created the tag. Okay, so index.js. So let's actually create this kind of stuff. So what do we do first to create? So we probably first need to access the canvas, right? So we need to query the entire thing. So it's going to be document query selector, and we're looking for specifically GL canvas. So what we're looking for is const canvas, like this. Oh, by the way, remember, let is not recognized as a keyword of JavaScript, which is kind of interesting. Isn't const and let were introduced at the same time, weren't they? I think. So, because it's kind of like from the same standard, aren't they? So it's kind of weird to support const but not support let. It's just like, what? So but the thing is, JavaScript inside TE reuses the configuration from CPP. So maybe const is coming from CPP. That could be a thing. That could be a thing. But we can actually fix it quite easily. So I'm gonna go to the CPP, CPP properties, and probably find, how is it called? JavaScript, right? JavaScript. I'm pretty sure we can find the JavaScript keywords. Here they are. So you have additional JavaScript keywords, and we're gonna just add Latin here, and it works. That's how quickly you can edit. Apparently. It's kind of interesting how quickly you can just modify some configurations. It automatically reloads them, and it's just available. You don't even have to restart it in majority of the cases. So that's pretty cool. It's a very interesting editor. It's really like I didn't get used to it yet, but it's very interesting. So const JL. So what we'll have to do here, we have to do canvas, get context, and I'm trying to get the context Webgl. I think that's how we do that, right? So this is how we do that. And if JL turn out to be null, that means we're incapable of initializing Webgl. Okay, so GL triple, yeah, it even has the ligatures for a triple one. That's pretty cool. If it's null, I think I'm gonna do something like console error. Does console error even work? I think it should work. Let me see. Console error. Yeah, it does work. Seems to be working. Nice. Your old ass browser does not support Webgl. Okay, so that looks okay. And what do we do next? I think we could put like maybe to the else, because I want to actually kind of stop the execution after this shit happens, because I don't want to continue shedding with the errors. So they solve this problem by just doing return, right? So they just do that by doing return. Maybe I can quite easily simply wrap all of that into a function, as I usually do. So maybe that's gonna be okay. So then 1, 2, 3, 4. Did we F? We did F, and we're already back. I see. So I don't know what happened. I'm sorry. So there's something with my internet that happens from time to time. I'm really sorry about that. So also maybe I want to enable wrapping around. So yeah, if something like this happens, I can at least see what's going on in there. So far, when this theme works correctly, it looks great, right? So it's just sometimes some themes are just not properly reused and whatnot. Right, and then here, if I do return, hopefully it will return out of the function. They added a button to reload player. Are you sure this is from Twitch itself and not from FFZ? Are you sure about that? Wait, is that it? That's actually pretty cool. So, oh, initialization is actually super simple. You just do that, and you can already start using everything. Okay, so that means you can do something like GL clear color, right? And let's actually clear it with the color of communism. A red one, my favorite color, GL clear, and it's gonna be GL color buffer bit. And this is, boys and girls, how web wins everywhere. They just make it easy to initialize OpenGL. Is that how they define functions in JS? Yes, exactly. This is how we have to do that. Horrible language, am I right? Absolutely horrible. Okay, so what do we have? I also need to include the JS and... Oh, that's interesting. So it still shows me that shit. I feel like maybe I should disable this theme until I actually finished, you know, converting it, because I think it's just too much. And I don't want to lose some of these things. So yeah, the way I'm gonna do that, I'm gonna do it like this. I want to mark it somehow. So this is my things, right? So this is my things that I introduced. So I will know what to look for. So this is a special marker for my styles when I enable them back. So one of the main problems with Site, by the way, is that it's not self-explorable. That's a huge problem of Site, seriously. It is not self-explorable, like for example Emacs or Vim or anything like that. So you cannot do shit. Oh my god. So, and I'm thinking to actually fix that at some point. So I'm planning to contribute to Site to add features which will enable like self-exploration. For example, I want to be able to click on particular styles here, right? On particular styles and see what style it is and quickly update it or something like that, or at least quickly add it to my configuration file. So yeah, and maybe that way it's gonna be just, you know, a little bit easier to work with in the future. Yeah, but for now, this editor is not really like, you know, super production ready, but it has a huge potential. I can see a huge potential that needs to be just unleashed. Yeah, it's just waiting to be unleashed. So that's pretty cool. Another cool thing is that the source code of the editor itself, it's written in C++, it's actually very readable, and it's relatively easy to find different places where the functionality is implemented, so it's easy to extend on a level of source code. So I really like that. Because some of the, like for example, Vim 7 is unextendable, and that's why one of the reasons why people fork it, because they want you to fucking clean up that mess. So the code of this one is actually pretty readable, so you can just extend it. Don't worry about it. Okay, so let's see if it will work now. And it didn't. I'm so happy. I'm so happy it didn't work. Absolutely beautiful. I wonder why it didn't work. I ran the program, I cleaned everything. Do I have to do that on every iteration or something? Oh, yeah, I know why. Because I didn't include the script. Yes. So it has to be script, src, and we're going to include index.js, and that should finally work. And now if I... there we go. So we initialized OpenGL successfully. Fucking-assfully. How about that? Isn't that amazing? I think it's getting fucking amazing. Oh my god. Sorry. So I can now put this thing here, and now it's black. So maybe we can also extend like this entire thing. So it's gonna be 8, then it's gonna be 6 or something, right? So to make this thing a little bit bigger, so we can work with it. Absolutely fucking epic. Now I know how to do WebGL. So can we do any other things? So see also introduction to WebGL fundamental. Oh, that is it apparently. Apparently that is it. Okay. So what's the next stage? Adding 2D context to a WebGL context. So what the fuck is this? Drawing the scene, the shaders, vertex shaders, fragment shaders. Okay. All right, that makes sense. Cool. Creating a square plane. Oh yeah. So but basically, yet another tutorial that tells you that to create a quad, you need to create a buffer and put all of your shit into that buffer. So that's pretty cool. I wonder if we can use the gray code trick from my C template. I wonder if we can do that. That would be kind of pogue in my opinion. So uniform vertex. So there's a position projection matrix. So there's too much. This is kind of like a strange tutorial. 2D context using shaders to apply code to WebGL animating objects. All right, let's try to create the vertex shaders and whatnot. Const vs source, right? And I wonder if I can do something like that. Does it support? It doesn't support the strings. Holy shit, unusable, unfucking usable. But maybe it's not that unusable, because oh, that's kind of cool. The fact that it doesn't support this kind of strings is actually beneficial, because we'll be able to have highlighting within the string literal. So that's actually perfect. That's actually absolutely perfect. Can your Visual Studio Code do that? So you thought it's a bug? You thought it's a bug? It's a motherfucking feature. Sorry. Anyway, so absolutely epic. Oh my god. So there's a vertex position, U model, view matrix, U projection matrix, and we just apply these matrices and everything is okay. Let me see. So I'm gonna just follow the tutorial, Vec 4. A vertex position, so it's going to be a vertex position. Then we're going to have a uniform where we can define the matrices. U model view matrix. So, and then we're going to have also a projection matrix. Okay, so this is called projection. I know that you were not serious, but I just can't shut up. Alright, so position. And now we have to multiply these things together. Right, so we just multiply them. It's kind of cool that shaders do support these multiplication automatically, so I don't have to implement it. They probably are done on the hardware level, so. Okay, so here's our vertex shader. Here's vertex shader, and now we need to define the fragment shader. Okay, so let me see. All right, so const fs source. Void main and so it's gonna be GL frag shader. GL frag color actually. So, and we're gonna use let's actually use yellow color this time to make sure that something is changing. And yeah, so now we need a function that initializes the shader program. So we have source codes, we load the shaders. Yeah, so okay, we still have to do this boilerplate. Still have to do that stupid boilerplate where we need to have a separate function for compiling the shaders, then checking whether it's compiled properly, right, and then reporting the errors and stuff like that. Fucking classic, fucking classic. So okay, remember how I said that web actually made it simpler? No, it didn't make it simple. OpenGL, yeah, it's a classic OpenGL. God fucking damn it, mate. So we need a function, something like function compile shader. I want to call it compile shader, so this is going to be source code. Maybe we'll call it shader source, right? So this is going to be shader source. By the way, do we have to put it like that? I think that you have to put it like that. So I think I want to split the screen and like cheat a little bit, you know? I like to cheat a little bit from time to time. So this is initializing the shader, and yeah, the first thing we need to do, we need to create the shader itself. So it's going to be GL create shader, and we also have to specify the type of that shader. Oh yeah, and we also need the context. Okay, so you have a GL shader and the source. So we create a shader of that specific type. All right. So do we have to? We probably don't have to check if it's if it created successfully or not. I don't think it matters that much. So so we associate the shader source with the shader, right? So here's the source, and then we're trying to compile this entire thing. GL compile shader, and there we go. So then we need to check the compilation status of the shader. Get shader parameter. So provide the shader, and we check its compile status. So if it did not work out properly, we have to probably return null. So that means we'll have to check it. Oh yeah, so we can get the shader info log to print it. Okay, so we can do something like console log, actually console error. So I'm not using alerts, but because I absolutely hate them. So I think they're cancer of web, and they shouldn't exist. Alerts are fucking disgusting. But I'm not a web developer, so don't listen to me. It's just my personal opinion. Alright, could not compile shader. And we're gonna do plus GL get shader info log shader. Okay, we can return null in that particular case. There we go. So yeah, hopefully that will work. And you also should delete the shader if this kind of shit happened. Okay, so let's GL delete the shader. Look at that. Oh, we have a garbage collector. Memory management is a solved problem. Still have to manage other resources manually. That is so cool. A solved problem, by the way. Solved problem. Okay, so... so what else do we have here? Yeah, and after that, if everything went okay, right, we have to return the shader. So the next thing we need to do, we need to link the program, right? So we need to link the program. Maybe before I'm gonna try to link it, I wanna just check if it didn't fail miserably. Like in console, I'm gonna just try to refresh it. Everything seems to be okay. One other thing I wanna do is probably just compile both of the programs, right? So I'm gonna create VS compile shader. So I'm gonna provide the GL and VS source. And how do I do that? So Vertex, I think this is how we do that, Vertex Shader, right? So this is going to be Vertex Shader, this one is going to be a Fragment Shader, Fragment Shader. So, and because of that, this is going to be FS source, and this one is going to be FS. And we might as well actually just print them, just to confirm that everything went okay. So it's going to be console log, it's going to be VS, and then it's going to be FS. So VS and FS, let me see. So here is a Webgl shader, and here is another Webgl shader. How about that? We have two Webgl shaders. That's pretty poog, not gonna lie. So another function that we want to have here. So I'm not even sure. Like, yeah, in C we have pretty much the same amount of code. So I'm just programming in C, but wrapped in JavaScript. So I'm gonna call it actually link program because in my opinion it makes more sense. GL VS shader and FS shader, right? FS shader. So I don't have to do that because I'm going to do that outside of this function, and let me create a program. So this is going to be a program, and I just create a program. Create program. So there we go. And we do attach shader, program VS shader, and then GL attach shader program FS shader. There we go. And then we try to link all of that. We're trying to link the program. So the program, there we go. So what do we have? So we also need to check the status of linkage. If not, GL get program parameter. Right, so it's a new program. GL link status. Right, so what we do in this particular case, we do the alert, but for some reason we do not delete the program. So in case of a shader, we do delete the program, but in case of a program, we do not delete the program. That's really strange, but okay. All right. So let's put it this way. Console log actually error. What's up, old man? So how is it going to be called? Linking program has failed, right? And we're going to just do plus GL get program info log program, right? And then we're going to return null in this particular case. We also probably have to check all of these nulls outside, but I couldn't be bothered to do that. So it's going to be return program. There we go. So, and the way we're going to do all of that is so might as well remove all of these things. It's going to be const program link program GL VSFS, and in link program I do accept GLFS. Okay, link program. Okay, so that's pretty cool. All right, so I guess we did everything. So if everything is correct, we shouldn't have any errors, and we do in fact not have any errors. Absolutely beautiful. So we initialized everything. So let me see what we have to do next. I guess we now have to activate the program. So they do some sort of like a program info. I don't give a shit about that. Then they're trying to initialize. Oh yeah, you also need to initialize buffers and whatnot. Yeah, classic. We also need to initialize buffers. So I'm gonna try to initialize buffers. So this is a quad, right? So this is the position of the quad. And after I'm done initializing the buffers, I'm gonna try my trick with a gray code. So because I think it's gonna be better. I think. All right, let's make a cup of tea. Does anyone have any questions while I'm making a cup of tea? Making tea. Feel free to ask questions. Let me just do it like this. Feel. English, by the way. How everyone is doing? Has anyone ever programmed in Webgl in production? Thank you, Adnan. Really appreciate it. That's a hot cup of questions. Question: what font is that? It's a Victor Monov. Victor Monov font. What do you think about Webgl? I don't think about it. That's why I sleep so well. It was using 3GS. That's cheating. We look at a really bad engine in Webgl 2 years ago. Nice. At least you built something. That already makes you more productive than majority of people. So yeah. But I got sick of JavaScript that I used the Java to JavaScript translator. Not a bad idea, considering that Java is a statically typed compiled language, so at least you have static typing. I'm planning to learn some JS game framework. Well, good luck with that. Good luck with that. Is there any like game engines for JavaScript? except 3JS, but I don't think 3JS is actually an engine, so, like a game engine. Too many, I see. Can you show plenty of them? Which one? P5 doesn't sound like tons of phaser. Okay, let's take a look at. But phaser is not a JavaScript, isn't it? It's like a C# phaser. The fast, fun, HTML. Oh, it's not. Okay, so it's a Blazor. Okay, I confused them. So desktop and mobile HTML5 game framework. Okay, cool. Yeah, I confused them. Ton of them. Okay, ton of them, and only one person mentioned one engine. Are you guys sure there's a ton of them? What are the other one? Come on. Ton of them. Fucking classic. Anyway, so this one is the top. Okay, I see. Babylon.js. Okay, Babylon.js. Web-based 3D. Unity. Well, technically, yes. Holy shit! What the fuck? Wait a second. Video. A demo of a web game engine. A demo of a web game engine. Fucking video. Welcome to 2021, everyone. All right. So let's continue. So So yeah, I'm still waiting for my kiddo. Does anyone have any other questions? Video game, yes, exactly, video game. Baked game engine, yeah. Can you render to a video element, or is it just a video? It's actually a very interesting question. I'm not sure if you can render to a video element. But that would be cool, I think. It's just a video. There's a FFmpeg in JS. What do you mean by that? What do you mean by that when you say something like this? Is that what you mean? I'm not sure what you mean. I just proved you wrong. There is no FFmpeg in JS. Okay, I'm gonna quickly pour a cup of water and we're gonna continue. WebAssembly. Nice. WebAssembly is slower than JS right now. Interesting. Could you show some benchmarks? I personally have an opposite experience with WebGL. For me, it was faster than JavaScript, but I programmed in WebAssembly directly. Right, so I didn't use any languages that compile to WebAssembly and generate shit ton of runtime on top of that, and don't optimize anything. I programmed in WebAssembly directly and directly wrote WebAssembly instructions. And the algorithm that I implemented in WebAssembly were significantly faster than the similar algorithm implemented in JavaScript. So I specifically benchmarked that. So for me, from my experience, it was actually faster. But I don't know what you are talking about. So maybe you're talking about some specific cases, some specific benchmarks, and I'm actually very interested. Could you please show me something? Depends how fast the JIT is on that particular function, so yeah, it varies widely. This is not the answer to my question, so, like, to my request rather. Can you show some benchmarks that also explain the environment at which it was run and what kind of languages they were using? I don't care about these kind of things, like I care about specific things, because, yeah. WebGL is faster than WebAssembly for graphical stuff, I think. Well, you can use WebGL and WebAssembly simultaneously, right? You can have a logic in WebAssembly that calls to JavaScript that then uses WebGL to render things. So it's kind of a strange statement, but I don't know. So yeah. Alrighty. Anyways. Okay. Let me see. So here is the thing. So we compile in this thing. So now I need to create the buffers. So let's actually go ahead and quickly do that. Oh, by the way, maybe we should make a stream where we do like a benchmarking of JavaScript and WebAssembly, but also handwritten WebAssembly, because I really like to write a WebAssembly manually. It's a lot of fun. So that will be actually kind of interesting. And it also will attract a lot of people, because people like this kind of masturbation. Okay, so we need to create a buffer, so we're initializing the buffers. Position buffer, GL create buffer. So we just created a buffer. So GL bind buffer, GL array buffer, position buffer. Position buffer. So we create the buffer, then we bind the buffer. And then we need to create an array of positions. All right, so it's going to be something like positions, and it's going to be something like this: -1, 1. So -1, 1. Okay, so that one. Then 1, 1 is that one. Okay, so it's basically starting from here and doing clockwise. But for you, it's counterclockwise because it's mirrored through the camera. Don't worry about it. But Zozin, you actually did the counterclockwise. Well, I just said that it's mirrored. Alright. Who am I talking? Actually, what's funny is that I actually legit had this interaction with the chat in the past, right? I was doing some like wave handing about clockwise and counterclockwise, and I said, okay, so this is a clockwise, but then I mentioned it's gonna be counterclockwise for you, and somebody in the chat said, but Zozin, it's clockwise for me. Like I just said that it's gonna be that way because of the mirroring, and you didn't listen. It was so funny, actually. Still remember that. It's just like I just told you. Anyway, and just. Why I keep remembering this kind of stuff? Like we should. Oh shit! You can have like a float 32 array. It's kind of cool that JavaScript these days like have this low-level structures, data structures, like specific float 32 arrays and stuff like that. It like JavaScript slowly turns into very scuffed, very inconvenient to use C. Yes, that's basically what's happening. So yeah, it's The time has come. T. Don't we all slowly move to the C? Yeah, it's actually... C is coming back. No matter how hard we try to get rid of the C, it just keep coming back. Just keep fucking coming back. There's nothing we can do about it. We're trying to create higher level languages, but they end up looking like C anyway because we need to make a shortcuts to the like low levels, and we end up with shit like float32 already in JavaScript. Can we increment the C joke, please? Yeah, C joke. There we go. 155 times. Nice. You're welcome to our C joke club. Imagine making the same joke over and over again more than 100 times. Holy shit. I'm pretty sure it's gonna become even funnier on 200 times. Imagine how funny it's gonna be on 1,000 times. Holy shit. We're all gonna laugh like crazy. Okay. So... Sorry. I think I had too much tea. So, yeah, Webgl buffer data. Array buffer. So save line. Oh, I'm sorry. So float 32 array, and we provide positions in here. It's gonna be GL static. So yeah. So essentially, this parameter indicates basically what exactly you're gonna do with that data. Are you gonna modify it in the future? Or is not going to be modified only red? So in our case, this data is probably going to be always red. That's why we're going to say it's a static draw, right? So I think this is what it means. So I think that's what it means. And after that, we just return the position buffer. That's pretty interesting. So this is initializing the buffer. Only one? Only one? Okay. So, but why do you return it like that? It's really strange. I think it's a pretty dumb way of... This code is horrible, actually. Why do you do this way? Why do you do this? Why do you do this to me? Position buffer. Okay, and... yeah, so we initialized everything. Cool. Rendering the scene. So then we draw the scene. Right. So we enable depth. So then the depth function, we prepare the matrices, and so on and so forth. We bind the buffers. All of the tutorials, OpenGL tutorials, are unreasonably complicated. They don't have to be that complicated. I know that for a fact, because you can demonstrate a lot of these things without making complicated tutorials like that, and they still choose to make it super complicated. It's just so sad. I guess we just have to follow. I guess we just have to follow. I kind of want to refactor that. Refactor that thing. Alrighty. So, so we have array buffer floating 32. So essentially, what I want to have here, I want to pass these positions as an argument to the function. So something like I want to make like this function make array buffer, right? You provide the GL. And you provide positions, right? So you provide positions. Might as well actually provide them as a new floating 32. Right. So, and the way we're gonna use that. Oh yeah, I recently changed the editor. I should probably update FAQ, but I'm not sure if I'm gonna stay in that editor for very long, so I'm not updating it. So the editor I'm using here is Site, that's what it's called. But it's just a text editor. Like, you can do the same shit in Vim or Emacs or in Sublime. So why do you care? Why do you care? They all do the same thing anyway. We need to create a buffer. So this is going to be a result, right? So I'm going to do GL create buffer, right? And then we bind the buffer to GL array buffer. So GL array buffer. And then GL buffer data, GL array buffer positions, GL static draw, and then I just return the result. And the way you're supposed to use this thing is going to be make array buffer GL new float 32, and we have to provide these positions in here. So let's quickly do that. So let's quickly copy paste this entire stuff. So this is an example of how you have to use that. So you make a buffer, and that gives you just the buffer. So yeah, make a array buffer out of that. So it would be kind of cool to also maybe customize this thing, or maybe static draw. Is there any reference guide for WebGL? WebGL reference, API reference. Any way to cheat the bot and send link? There is a couple of ways, but you're gonna get banned, so feel free to do that. Feel free to try that. So overview. OpenGL 1.0 specification. But I don't care about specification though. I just want a reference guide. Quick reference card. So maybe we're gonna go here. Oh my god. These kind of cards are like never useful, by the way, because they're too dense. I can never understand them. They're just too fucking dense. Like, how do you find any useful information out of that thing? It's just horrible. Yeah, they're weird. I never found them useful. I literally never found them useful. They're useless. Holy shit. So it's just so dumb. Okay. WebGL buffer. I just wanted like a list of functions. Okay. Buffer data, right? Okay, so there's example, but do you have? Okay, that's pretty cool. It's called usage. It's funny how they're using C signatures in the WebGL specification. They're using C signatures in the WebGL specification. It's so funny. It's so funny. Alright, so maybe I'm gonna actually call usage as well. So this one is gonna be, well, yeah, usage. So I'm gonna set the usage here. And it's gonna be GL static draw. Yeah, something like that. Oh, so you link the benchmark. Okay. Alright, so collision detection. C code. How the C code was compiled. Compiled shell script. MCC. Optimized size, but not optimized code. I see. It only optimized size, which is interesting. So why would it do that? Why would you don't do like O3 or something? Because obviously, like JavaScript probably optimizes its code and C doesn't. That's really interesting. But I think it's not fair comparison because JavaScript, like V8, definitely optimizes everything. I ran it, and for me, WebAssembly was faster. Also, when were the benchmark made? When were they made? Maybe they were made at the time where it was not true, so I don't know. But anyway, I think it's a pretty interesting thing to go through at some point, so I'm gonna actually go ahead and do the following thing. I'm gonna go to our Discord server. Right, I'm gonna go to my Discord server. It's our Discord server. And maybe I'm gonna create a channel where I'm gonna put different topics. So how should I call the channel where we're gonna put topics? You have to click run. No, I don't have to click it. I don't owe anything to anyone. I'm sorry, Annabeth. I don't have to do that. So how should we call it? I don't want to call it Friday, but so topics, maybe topics. Stream topics. Yeah, let's call it stream topics, and let's just create the channel. So, and I'm gonna put it somewhere, I don't know, maybe above the food and below the Japanese animation channel. So I'm gonna put this thing here, and then I'm gonna just pin this entire thing. So pin the message. Yeah, so from time to time I'm gonna actually go to the pinned messages and just look at them and see something. And you also feel free to suggest something, but I do not guarantee that I'm gonna read your message there. So yeah. So yeah, join our Discord server. We have a Japanese animation channel. if you guys want to join. Alright. Does your server have a Japanese animation channel? I don't think so. I don't think so. This is not a web channel. This is a Japanese animations channel. Okay. Alrighty. Make array buffer. So thank you for the link, by the way. Vertex, trust Vertex. So now you should be able to send links without being timed out. So everything should be okay now. Because this particular benchmark sounds like a pretty cool topic for Friday. All right, so yeah, I think I'm gonna remove this entire Scheiße, and now we need to draw this scene, right? So we draw the buffers and so on and so forth. Okay, so let me put this thing here. Function draw scene. So we're gonna provide the GL, the program, and a buffer, right? We're gonna provide these things, and I guess I'm gonna do it like that. GL clear color. So we clear everything with black color. So to be fair, I think there is like a good practice, I heard at least, to clear with like a very bright color. So if, for example, you fuck up something in the shader, and if you see that color, you would, yeah, it will basically indicate you that you did something wrong or something. Have you guys heard about that practice? I'm not sure how useful that practice is, but maybe we can try to do that. Anyway, so we also clear the depth buffer, clear the depth. And we also enable the depth test before, like after we clear the depth. That's very interesting. On macOS, I can't go to the server. Do you? I think we have something disabled. I think I disabled sending messages to plebs. No, plebs can send messages there, so I don't know what's wrong. Alright, so that's a very cool example, like, clear everything. Okay, what the fuck is this? What the hell is this example? Holy shit, like, who wrote that? Near things obscure far things. Oh, that's actually something that I should enable in my array lead game, which I don't develop, by the way. Cool. This example is such a mess, like, holy shit. It's almost like it's intentionally just like smashed together to make it as obscure as possible. Like, why the fuck do you do that? Like, you don't have to do it this way. You just don't have to do it this way. So matrix GL matrix JS always has the first. What the fuck is GL matrix JS? Why there is a third party wait, GL matrix JS. Where did you get GL matrix JS? Excuse me? Holy shit, this is so bad. Holy, wait. Mat4. There's no such thing as Mat4. They're using some sort of third-party dependency called GL matrix JS, and they're not even mentioning that anywhere. Holy shit, oh my god. Is that true? Is that a third-party dependency, GL matrix JS? This is so bad. Wait. Oh my god. Yeah, they're using something. This is documentation about WebGL, and like, why do you use third-party dependency? Like, I'm reading that specifically to learn about WebGL and shit, and it's just holy shit. Oh my god, our industry is fucking doomed. Let me see. I want to make a small break because I want to pee. So let me do small. Yeah, let me do that in Emacs. Real quick. How many minutes do I want to do? I think 3 minutes should be alright, because I also need to refill the water. Alright, let's make a small break. You guys have fun. What's up? Epic Gamers, how's it going? Welcome back to back. So where is the draw scene? Right, so here's the draw scene. We enable that shit and we do gel clear color. Clear gel. It's kind of strange. Clear the canvas before the start. Yeah. So this is my mistake. Yeah, I thought this clears the depth. This call clears the depth. And this one sets with which we clear the depth. That's why I suppose that's okay to do that before we enable depth. And depth that has nothing to do with all that. I'm an idiot, okay. I see it now. Color buffer bit, yeah. Depth buffer bit. Okay, create perspective matrix. To be fair, I don't want to do matrix shit right now, right? So essentially what I want to do, I want to map the vertex position to the GL position. So I don't think, like for this particular example, doing matrix transformation is just too much. It's such an overkill, and that's why I hate OpenGL tutorials, right? For such a simple demonstration, this is a huge overkill that turns away a lot of people, right? You just don't need to do that, like especially for 2D. Like, as a matter of fact, you can make the entire like 2D games in OpenGL without even doing anything with matrices. Like you just don't need matrices like usually. You can, yeah, unless you're doing something complicated, because they simplify the complicated stuff, because you can basically combine several operations into a single operation, and also you can pre-compute matrices. But if you're not doing anything fancy, you just don't need them. People were writing like 2D games 50 years ago without using any matrices at all. They would just had variables x and y and dx and dy. So, and for the sake of learning, you want to keep things simple, and it's just people don't understand that. No, people don't understand that. So we don't need to translate anything in here, we don't need that. Alright, so we have this buffer, right? We need to bind it, and we also need to GL vertex attrib pointer. This one is going to be interesting actually. Vertex position. Oh boy. Okay. So we can omit all of that, but then we start to bind buffers and stuff like that. Okay. GL bind buffer, GL array buffer, and I can just use this buffer like this because I directly provide the buffer here when I render the scene. So the next thing I need to do vertex attrib pointer, and let me actually use docs.gl. I think it's going to be a little bit easier. GL vertex attrib pointer. Right, so this is basically what we're going to have here. So specify the index of the generic vertex attribute to be modified, the index, and we get the index from a thing called vertex position, and I'm pretty sure vertex position, yes, GL get attribute location, yes. So that's basically how we do that. I see what they did here. Okay. So that's very interesting. That's a very interesting way of doing that, I suppose. Alright, so I can make it like this then. can extract it from here. So this one is going to be something like this. Alright, const. So this is a shader program. I'm gonna fuck it up so hard, by the way. So, but I don't need uniforms at least. At least I don't need uniforms. So, which is already a good thing. Draw scene. Alright, it's gonna be draw scene. Draw scene. I'm sorry. Vertex attrib point. Vertex position. Num components. So what is a num component? So we have 2 values per iteration. Yeah, that's true. Num components. So we're going to put the const num components 2. And what do we say here? So pull out 2 values per iteration. Like this. So then we have a type, which is GL float. Type normalized stride offset. This is like a basically named arguments. Because of the lack of the named arguments, you create separate variables in here and then you put these variables there. To be fair, in JavaScript, it would be actually more convenient if the GL functions would accept objects with, you know, things like type, GL float, right, and then num components too. So we can actually pass these things around. That would be actually kind of convenient. And it wouldn't actually violate, in my opinion, the API too much, because the API is already incompatible with the C code anyway, so we can make it actually as a little bit nicer by passing objects around. But I don't know. By the way, is there any plans for named arguments on JavaScript in the future? Are we dead? Is the chat okay? Okay, so I guess the chat is dead. So, all right. All right. I guess they don't want named argument at all. Well, probably because of the reasons I just explained. Because you can do things. Because you can pass an object. Right. So basically, you can do something like call kw args, right, and just use them here. Kw args a, and so on and so forth, and then just call it like this, right? Probably because of that. Right. And if that's true, the question is why WebGL developers didn't make OpenGL calls that accept objects, because OpenGL calls have a lot of arguments usually, right? And it would be quite convenient if you could pass objects there, right? So it would be kind of cool. I have a feeling, I have an interesting feeling that the WebGL specification was designed by people who don't program in JavaScript. You fucking know that, because like an average JavaScript developer, they probably know nothing about like low-level graphics APIs, right? So they had to hire people who are C/C++ developers who do low-level computer graphics all the time. So they were forced to learn a little bit of JavaScript, just to design that specification. So, and they basically what they did, they just mapped C calls to that, and that's probably how it went. This is how I imagine. What's an example of a language which has named arguments? Python! Python has named arguments. Scala, I think Scala has named arguments. Actually, a lot of languages have named arguments. Maybe Python object is slower, and if you need arguments to wrapper functions, but it doesn't. V8 does a lot of magic optimizations and stuff like that. It could probably detect that and optimize. I don't know. Anyway, so we have num components, and let's introduce other things. So this is going to be the type. GL float. GL float. The data in the buffer is 32-bit floats, right? Normalize. Don't normalize anything. Don't normalize. I like this code. Normalize equal false. Comment. Don't normalize. Thank you. That's very cool. That's so cool. Let's try it. How many bytes to get from one set of values to the next? 0. Use type and components above. Okay, so that's actually a pretty good comment. That's actually a very good comment that explains things. I like that. So here's our stride. And offset, how many bytes inside the buffer to start from? Well, in that case, it's actually going to be 0. Right, so, and I'm going to also copy how many bytes inside the buffer to start from. Alright, so now we're just using all of that shite for the vertex attrib pointer. Type, normalize, stride, offset, okay, cool. So, and then, so here's the vertex position. We also enable attrib array thingy, otherwise you won't be able to use it. GL enable vertex attrib array. So we use program and vertex position. There we go. So after that we have to use the program, right? We have to use the program like that. So then we starting to have this matrices, which I don't really care about. And the next thing we need to do the draw call. Speaking of, I think I need to wrap this entire stuff into its separate scope, because I'm using like variables with the same names. So I'm gonna put it like that. There we go. So we're gonna have const offset 0, const vertex count is gonna be 4, GL draw arrays, GL well, since we're using triangle strip, right? Triangle strip. I think our trick with gray code is not gonna work, unfortunately, which is kind of sad, but it is what it is. And yeah, we implemented the draw scene. Draw scene. I guess that's what we did. So interestingly enough, so this transformation actually shrinks the buffer a little bit. So that means we'll have to probably shrink these things here as well. So we compile the program, so we also link the program in here. So what I'm thinking is that now I need to create the buffer in the same place, right? I need to create a buffer in the same place. So here's the Vertex Shader, here's the Fragment Shader, then I'm doing make array buffer. So this one is going to become that. So I'm going to remove this thing. Const buffer. There we go. And maybe I want to do something like this, right? 0.5. I didn't want to modify that one. So here's the buffer. Now, after we prepared everything, we compiled shader, fragment shader, vertex shader program, and we have a buffer. We're trying to draw the scene, right? And the way we draw the scene is we provide GL program and the buffer, and that should work, I think, but I don't think it will right away because I'm pretty sure I made a fucky-wacky somewhere. So I bind the buffer, I prepare everything, then I use the program. And do I need to call something to display? I don't think I need to call something to display. I think it automatically displays everything. So that should be it. That should be actually it, I think. So a vertex program, didn't I put a program there? Where? Oh yeah, that's true. Okay. Alright, so let's see if it's gonna work now. And it didn't work because execute bind buffer on GL2 arguments, but only one provided. So let me see where exactly that happened. GL bind buffer, so I have to provide yeah, I have to provide the buffer itself as well. So bind buffer, so where's the buffer? Buffer has to be the second thing, I suppose. Alright, that's pretty cool. And it worked. No, not really. Yeah, so it didn't really work because, yeah, so remember how I said that setting this color to something very bright is actually like a good idea? Because if you did a fucky wacky, it will just indicate that you did a fucky wacky, and there you go, it showed you. So, and I made a typo in here, so I actually had like 3R in there, 3R. Okay, so if I... there we go. That was easy. Without any matrices, by the way. Without any matrices. So... this tutorial is shit. Holy fuck. It's the worst tutorial I've ever seen in my entire life. You just don't fucking need matrices. Like, dude, come on. And you want to move things around. Okay, so maybe you can say you can want to move things around, but to move things around, I don't know. Just makes me sad. Okay, so we can do this kind of shit. Maybe we can change the background to something. So if the background is gonna be that, I'm just thinking what we can do there. What we can do. I wanna turn this entire thing into 1 by 1, right? So actually 2 by 2, right? So shit. I need to get used to these multiple cursors for this editor, right? So this is gonna be completely yellow. Right, it's gonna be completely yellow, and in the fragment shader we're gonna make it completely black as well, right? So this is that. Okay, it's black, but we still clean with the yellow color just in case you did a fucky wacky, right? So for example, we can find draw array and we can put R in here, and that draws everything with green automatically to indicate that you fucked up something, so that's pretty cool. But the correct color has to be black, right? So yeah, I think I'm gonna keep using this trick, but maybe instead of green we can use red to sort of indicate like the error. It has to be like a red error, right? I think it's a good idea. Yeah. So basically you fucked up, and now we put it like this and it's gonna be black. Cool. So now we can use fragment shaders to draw things like into a texture, right? So we have a quad, and now within the fragment shader we can do things. But to do things we need to have uniforms inside of the shader, right? We have to have uniforms. So the question is how, like, the code suggests pretty cool idea. The code suggests pretty cool idea to have some sort of object, right? To have some sort of object where you have the following fields. You have program, where you have your WebGL program, and then you could have a sub-object uniforms, right? Uniforms, and you can access those uniforms by particular names. For example, something like position, right? And it's gonna have like a uniform location, and yeah, your actual program is gonna be this object, and you can access these things like that, and you can also access like attributes and so on and so forth. I think it's a pretty cool idea, but I'm not sure how convenient it is to construct these kind of things, right? So maybe we're gonna go ahead and introduce some classes. SIT interesting, yeah, it's an interesting editor. It is interesting editor, not gonna lie. Classes, yes. C with classes. So maybe we're gonna have something like program, right? And it is going to have all of that stuff. But to be fair, it will require a lot of things. So how are we gonna construct a program? So constructor. So maybe it's gonna accept their source and the fast source, and basically construct everything inside of this class. And also, it would be kind of cool if you could explore attributes. Oh shit, I just got a kind of cool idea. Imagine if program class would analyze the source and extract the list of all of the attributes and uniforms, and automatically call get uniform location and get attribute location and populate the object. This is such a cool idea. This is such a scuffed and cool idea. I love it. Holy shit. But the question is why WebGL itself cannot do that. Well, I mean, I can't know why, but still. What do you guys think? So essentially, it's just like searching for this keyword, searching for attribute or for uniform, right? And just calling the corresponding things. That would be kind of cool, but I don't know. So here we have compile shader. So I'm just thinking what would be the best thing to do. I want to make a small break because my brain was working really hard trying to simplify this example, so I'm a little bit tired right now. And now I'm forced to think how to refactor all of that to use classes and stuff like that. And it's just a little bit exhausting. Okay, go. I wish I could use Typescript, but that will require setting up the npm project, and I don't like it. Is it possible to use Typescript as a standalone thing without npm? By the way, does anyone know? Because I don't really want to set up npm projects and all this shit. Like, it's just, I'm too old for that. Okay, too old for that. Dino? No, it's not the TypeScript. I need the TypeScript compiler. So via npm, you can do that with Visual Studio. Okay. Compatible transpilers. Next. Okay, so it's literally impossible. You can use TSC, I think. Globally installing. We can try to globally install it, but I hate globally installing things. So, and because it tries to literally install it like in the system. I guess I'll pass. I want to keep things simple to set up. Okay, so let's introduce something like class program, and it's going to be constructor, right? Constructor. Constructor, and so what we're gonna accept here, we're gonna accept VS source and VFS source. VS source and FS source, and I really want to automatically populate the uniforms and stuff like that. How can I provide the uniforms though? How can I provide the uniforms? Maybe I shouldn't do. So I do that. You know what? I think I'm not gonna do that. I think I'm gonna just construct the program myself because it seems to be like the best way to do that anyway. So, and I think this, then we can delete shaders. Delete shader VS, and then I'm going to duplicate FS, so we are removing all of them. So I linked the program, and now I can construct. So I probably also should call it shader program, right? Shader program. Maybe not. So now, what I want to do? Let's call it main program, right? So it's going to be main program, which has program as a program. I'm pretty sure you can do something like that, but I don't remember if it will work properly. I'm going to just put it like that just in case. Uniforms, and we're going to have uniforms in here. And uniforms, what kind of uniforms we want to have? So let me see. So in the Fragment Shader, we're going to have uniform float scale, right? So it's going to be float scale and uniform v2 offset, right? So we have these two for uniforms, and I should actually put them there, right? I should actually put them there. And it would be kind of cool to automatically populate them, so... So we need the function construct program. Construct program. So program and uniforms. So yeah, it's going to be construct program. Construct program will provide the program, and we have to do the uniforms and stuff. So let me see. Scale. Oh yeah, so I probably have to... Do I have to provide the types? I'm not sure if I have to provide the types for all of this shit. Maybe not. So it's gonna be just this thing. Or it's gonna be scale and offset. So, and I want this thing to automatically construct everything for me. So the way we're gonna do that... so this is gonna be a result. Let result. It's gonna be program, and uniforms empty thing, and I need to iterate through this object. So JavaScript for each. Maybe I can use that one. Yeah, let's use for each. That is that one. Okay, so uniforms for each. Right, so we're gonna have a single name. Okay, so then I can do result uniforms, And to be fair, I want it to be like an object, so that means I probably have to do it like this. So it's gonna be name equal, and now I have to do this GL. GL attribute GL uniform location. Where is the GL uniform location? Where is the GL uniform location? I get okay, so it's that one. All right. So yeah, I need this thing in here. GL get and of course I have to do like GL in here. So program, and here is the name. So that's probably how we're gonna do that. That's probably how we're gonna do that, and then we're gonna return this entire thing. So maybe this one could be const because I'm not planning to reassigning it, and yeah, const it doesn't make this entire thing const. All right, so that's a pretty good way to construct a program. It's really so we have to deal with the scuffness of two things. We have to deal with the scuffness of JavaScript and the scuffness of OpenGL. It's just so fucking goddamn painful. Holy shit. Two things like designed horribly come together. Two things designed horribly come together. All right. Anyways. So, all right. So we construct this program, and so maybe I wanna remove this draw scene, and I wanna do console log main program. All right, so what do we got? What do we got? So let me see if it's gonna work now. Okay, so could not compile shader null. Get shader log attempt to use deleted objects. Okay, so that makes sense. So essentially okay, so I shouldn't delete those shaders then. It's kind of strange because I remember after you link the program you can delete them, but apparently you cannot. Sure. Attempt to use deleted object, but I don't delete them anymore, do I? Did it? Okay, so where is that? Compile shader. That's very strange. That's really, really strange. Like, what the hell has happened? It's kinda... doesn't make any sense, to be fair. I need to make a small break. I'm really, like... Alright, so... and... is it because I fucked up the uniform? Okay, so I can try to remove the uniform. Holy shit, this is so bad. I think I know what was the problem. Okay, so for each uniforms, whatever. So this is a uniforms of undefined. Whatever, let's not construct the program. Okay, so I'm not gonna construct it. Let me see what's gonna happen. Main program is not defined. Yeah, let's remove all of that. This is so bad. So if I actually add uniforms in here, right? If I add uniforms in here, yeah. Holy shit. Holy shit, this is so goddamn bad, isn't it? So, like, this is the shader compilation error, and this is what it tells me. Attempt to use deleted object. Holy shit, this is so bad. Who the fuck are you, by the way? I keep seeing you trying to annoy me in the chat. I haven't seen you. Let me see. Okay, I'm gonna time you out for 1 hour, I think. 1 hour is gonna be enough for you. So, alright, I'm gonna make a cup of tea. Think is because when you get a shader compile error, you delete the shader. Ah, that's a... But that was taken from the tutorial. That was taken from the tutorial. Wait a second. Oh, okay. Alright, fair enough. I actually did that in a different order. Okay. That makes sense. So it's... I actually shoot myself in the leg. Yeah. So, yeah. I just put that in a different order. Okay. That's a very interesting way to shoot your leg, not gonna lie. That's a very interesting way to do that. Yeah, exactly. Holy shit, exactly. Alright, so let me see. Making tea. Feel free to ask questions. Alright, so yeah. Interesting. Yeah, so yeah, I'm just waiting for the kettle. So if anyone has any questions, feel free to ask them. WebGL is just a WASM wrapper around OpenGL? No. By definition of WASM, it is not, as far as I know. What kind of games do you want to make with WebGL? Platformers, strategy, puzzles? Whatever. I don't really care about any specific games. I just want to learn how to use WebGL. I don't think WebGL cares what kind of games you're trying to make with it. I'm pretty sure WebGL was designed the game genre agnostic. So, yeah. Does make sense. It would be kind of weird to develop like a graphical API in which you can develop only platformers. It would be kind of weird, and then call that graphical API general purpose graphical API, which I think I would assume WebGL claims to be. Right, it's a general purpose graphical API. So I'm pretty sure WebGL is genre agnostic. So I don't care personally, right? So, alright, so my kettle is ready, so let's actually pour a cup of water and continue. It's a good question, G. It's a good question. Sometimes I think I should just stop streaming and find a job, because this shit kind of starts to really affect my mental health. So yeah, I should probably just stop and change completely my life, but I can't. I cannot do that anymore. So let's continue. So this is what we have, and if we take a look at the error, all right, finally, so we have a proper compilation error. No precision defined for float. That's actually good. How do you define precision for floats? I don't remember though. GLSL float precision. So we have low precision. What kind of precision? So let's say it's high P. So where do you put it? Okay, it's just high P. High P. Wonder if it's gonna actually do something. Okay. No precision defined for float. And where exactly that happened? Okay, so I think I need to, when I compile the shader, I also need to specify like what shader did I fail to compile. Right, but it's kind of difficult to specify that, because if I just use the type to compile shader, right, and I can do something like plus type, right, and something like this, right, I don't think it's gonna print a human readable shader type. I don't think it's gonna be human readable shader type. Yeah, I forgot the plus here. Yeah, so it gives you the number. Alright, so we need to implement like a conversion of some sort, like shader type. Shader type as string, and we're gonna provide this thing here, and we can do things like if type equal GL, GL Fragment Shader, right, we can return literally Fragment Shader, right, and then we can duplicate this entire stuff and go somewhere here and do Vertex Shader. There we go. It's pretty cool. Otherwise we can return unknown, right. Yeah, and now if I refresh this entire thing, it's and also I have to do it like this. Oh, by the way, I don't have to do it like this. I can just use the string interpolated stuff. So it could be shader type as string type, and it's gonna be like this. So, and unfortunately, it's not gonna really work that well. I'm doing it completely incorrectly. GL is not defined. Oh, you have to provide the GL here as well. All right. Alright. I should not forget to put it like this then. And a Fragment Shader. Thank you so much, Lindro Braga, for 4 months of Twitch Prime subscription. Thank you. And welcome to our epic WebGL club. How about that? So we know for sure that it's a fragment. Well, I mean, I was modifying the Fragment Shader, but I still want to implement this feature because I think it's going to be useful in the future anyway, because we need to distinguish between the shaders and stuff like that. We still need to do that. And I also want to have the highlighting for the string interpolated strings, but unfortunately it's not a thing I can have. And I forgot what I was doing. So it's a 4th line. 0, 1, 2, 3, 4. So it didn't work, by the way, right? So what if I put it like this? Oh, maybe I have to announce. Oh, I remember that. It's so dumb. Yes. I have to do it like that. It's so dumb. Oh my god. Yes. And sometimes you have to do that. Sometimes you don't have to do that. It's just hate it. All right, everything seems to be working. Finally. All right, cool. So now when I'm constructing the program, right? So I do construct program. Yeah, we do that. We prepare on the uniforms, and let's see if it's gonna work now. Cannot a property or reach of undefined. And why do you say it is undefined? Because I obviously... Okay, if I got GL, okay, so if I got GL, now it seems to be working, and now if I enable this entire thing, we do have uniforms here. Right, we have offset and scale, and all of them are null because they didn't fucking work. Beautiful, I'm really happy. So the question is why it didn't work properly. Let's try to figure that out. Okay, so maybe I don't understand how to work with objects. So JavaScript object add new field or something. So this is probably what we want to have here. Key value paired to the JavaScript object. Or maybe the call didn't work properly. It could be something like that. Yes, the call. Oh yeah, I know why. Because No, I do have these things here, so everything should be okay. Well, yeah, so everything works okay. This is exactly how I do that. Objects assign. Not really. But yeah, so location, uniform location was not taken correctly for some reason. I don't know how. Why? Get uniform location. So all of them became null, right? You can clearly see that. So we have a Webgl program, which makes sense, but the offset and scale are nulls. So we are about to figure out why. Finally, a good cup of tea. So maybe I'm using GL get uniform location. We can try to debug this shit, why not? Step over. I probably want to go here somewhere. Name scale. So here's the program. The name is equal to scale. And let me see if it does have a uniform scale. Here it is, here's the scale. And if I step over, so result has it equal to null. And we're passing compiled program instead of shader program. Yes. Bind the program, that's a good point. Goddamn, fuck, thank you. I made the same mistake. I cannot remember how many times I made the same mistake over and over again. Holy shit, thank you so much. Oh my god. And what's interesting, funny thing, I think, yeah, at the beginning of the stream, I thought, yeah, I'm gonna actually struggle with that yet again, and I completely forgot about it. I don't work with OpenGL regularly, but every time I work with it, I make this mistake over and over again. I don't think it's a mistake. I think it's a legit flaw in the design of OpenGL. I cannot justify this behavior. I literally cannot justify this behavior, seriously. Because the uniforms are part of the shader program interface. They are part of its interface, and literally what compilers do, they optimized out the interface. It's as insane as if, for example, a C compiler would optimize away external fucking symbols of the static library or of the object file. If you say something like that, if you suggest something like that to a C compiler developer, they will call you insane. But it's completely okay here to optimize out parts of the public fucking interface. Like, I keep thinking about this kind of decision over and over again, and I cannot justify it for myself. Does anyone have any justification for this stupid ass behavior? Does anyone have it? Because I cannot think of a single one. This is so dumb. There's literally no justification. Like, I do understand optimizing out this, but this is not a part of the public interface. And that makes sense, sure. But this makes it a public interface, hence you should not optimize it out. Holy fucking shit. It's just, it is fucking dumb. Like, I hope whoever come up with that decision is fired. I really hope so. Because that's like, no. Optimize away types completely for cases just pointers, yeah. And since I don't work with OpenGL regularly, I keep forgetting about that quirk. I literally keep forgetting about it, and I get frustrated every time when I go back to OpenGL. Thank you so much, Foss. Thank you. Really appreciate for reminding about this. I just, holy fuck. Just let's see optimize main out. Yeah, who uses main? Who calls main? Nobody calls main in the entire program. We can optimize it out, right? So, fuck's sake. All right. So, so what we're gonna do here? So if I do scale. Oh yeah, and scale has to be actually part of the... Well, no, not really. So we also in the OpenGL have the other thing, right? So let me see. GLSL fragment shader variables. What kind of variables? I do know that we have like a fragment coordinates or something. GL frag coord. Maybe I already opened. Here, this built-in variables GL frag coord. Here we go. So this is probably what we want to use here. GL frag coord, and we need to take a look at the thing. Right, and I can probably take a look at X, right? And so I'm pretty sure it is in pixels, right? So it is in pixels. If X or whatever this screen, like some sort of screen units or whatnot, if it's less than, let's say 800, and GL frag coord Y less than 600, we're gonna render this entire thing with some other color, for example white color. Otherwise we're gonna render it with a black one. So this is a white one, and right, and that one is going to be like this. This one is gonna be black one. All right. And did it work? I think it did work. Yeah. No, it didn't work. So how can I remove all of the breakpoints from this shit? I don't remember. I don't even know. Probably have to do that manually. So let's take a look at the console. Fragment shader, wrong operator, okay. Left-hand operator, medium float, and a right operator, const int. Oh, okay, so they have to be floats. Yeah. All right. So apparently it's very strict. Would you look at that? And if I, for example, make it something like this, right, it does not affect the final color whatsoever. Which is kind of weird, right? Oh, because I never draw anything. Okay, so that I fucking didn't. All right, so that is yellowish. That is very yellowish, which is nice. Okay, so now if I apply, if I actually multiply it by half, right? So I multiply the sizes by half, it will make it smaller, right? It will make it smaller. There we go. So, so that means we can now use the scale. We can now use the scale. I can actually multiply this by scale, right? And it's probably not going to work completely, right? It's probably equal to 0 because we never set the scale. And GL GL uniform. Yeah, so we have to set the matrix. But here is the interesting thing. Can I just do GL uniform? Just GL uniform. So after I did that, it's going to be GL uniform. By the way, yeah, probably GL uniform 1F. It's going to be main program uniforms, scale, and we're going to make a scale equal to 1. So we're setting like that, and it didn't work. Yay! It didn't fucking work. But did it fail? Did it fail? Uniform location not for current program. Okay, so I have to bind the program then. All right, GL use program. Main program. Okay. Yeah, it worked, and now I can apply the scale, like half of the scale, and yeah, now I have this kind of thing. Okay, so I can also, so I'm passing parameter to the shader. And that's pretty pogue. So another thing I can do as well is probably pass the position, right? So, but to be able to do that, I need to use the position somewhere, right? I need to use the position somewhere. So also we have hard-coded sizes, which is not ideal, but there's nothing much I can do about it. So we can have width. And this one is going to be height. Height. 600, and let's actually do that. So it's going to be width. Okay, and this is going to be height. Can I'm probably not. So how are we going to offset all of that? So essentially, if the position is greater, that means we just have to add the offset. Oh, that's very interesting. We can do something like this. It's going to be vector2 point. You take GL frag coordinates as xy and add offset, right? And then you keep comparing actually p coordinates, right? So px and py. There we go. So interestingly enough, okay, so that makes sense. So that's pretty cool. Can you have something like constant here? Is that a, well, I mean, I cannot rely on the highlighting of site E because it doesn't really know what it's talking about, but yeah. That's pretty pogue overall. And the most interesting thing, I can use C preprocessor within shaders. I keep talking about that, how weird it is, but apparently I can do that. Because apparently the shader compiler has its own built-in C preprocessor. Yeah, CPP and JS. It's not really CPP and JS, it's a CPP in the shader compiler. Yes, it does work. So, well, at least it works in shaders when I programmed in C, right? So, and it feels like the GLSL compiler. Don't be ashamed, GM. It's completely normal. Don't worry about it. All right. So, what I wanted to say, like I saw people using C preprocessor in shaders all the time in different engines and stuff like that, and I always assumed that they had to code it themselves. I always assumed that they had to code it themselves, so they would take the string of the shader and they will pass it to the C preprocessor and stuff like that. But apparently no, OpenGL does that for you somehow. Yeah, it's a JS binding for OpenGL. It is, so that should work. We haven't checked it yet, but yeah, we need to check. Zozin, why your code is not finished? Zozin, your code is not finished. All right, so what do we have? So we need to set the position, I think. GL uniform, I think it's gonna be 2F, main program uniforms, is gonna be offset. Maybe I should call it position actually, right? So, and we're gonna set it to, I guess, I don't know, 100 by 100? I think 100 by 100 sounds like a good idea. Okay, and it actually moved it in an opposite direction, so that probably means I have to subtract this entire shite. So I have to do minus. And did it work? It kinda did, but not really. Oh yeah, I have to actually compare it. Yeah, I think I know what I have to do. Oh, that's a cool idea. Oh shit, that's actually a super cool idea. Thank you. Oh shit. We can even, yeah, we can even take the size from these things at runtime and then construct a new shader out of it. Holy shit. Holy fucking shit. Who needs uniform? Man, uniforms solve a different problem. They help you to pass parameters to already compiled shader. But string interpolation passes the parameters before the compilation. So it's kind of a different times of passing parameters, so I don't think you can replace this kind of feature with uniforms. Hello Moragi, welcome to the stream, how are you doing? Welcome. Oh, okay, I see. Sorry. What did I put here? So yeah, I'm actually computing everything incorrectly. That's what I wanted to say. So the offset is going to be like this. So it has to be offset x less or equal px, and px is that multiplied by scale and shit. Offset y. And what the fuck am I doing here? Like it has to be like this. Py and py less than scale. So maybe it has to be even like this. So I'm gonna put it like that. Yeah. Good to see some JS on the stream. Okay, so it's so funny. Like I programmed in several commercial projects in JavaScript, both backend and frontend, and I quite often do like occasional JavaScript streams. And the funniest thing is, every time I do this occasional JavaScript stream, everyone, holy shit, he's programming in JavaScript, he never programmed in JavaScript, holy shit, oh, this is so funny, and it's every time. It's like, every time people see my streams, they make a lot of assumptions about what I know about technologies and what I do not know about them. Like, it's so funny. Like, and I've done so many JavaScript streams over like my entire streaming career. Like, I've done a lot of JavaScript stream, but every time I do that, like everyone, holy shit! Oh! By the way, did you guys know that Casey Moratori, the Handmade Hero guy, he programs in JavaScript? Did you guys know that? Holy shit! Handmade Hero, the website. He actually made this website himself, and this website has quite a lot of JavaScript features and stuff like that. It integrates with Twitch, it updates this kind of schedule and stuff like that, and I think it integrates with like chat and whatnot, and he coded all of that himself in JavaScript. Yes. Did you guys know that? Holy shit, a C++ guy programs in JavaScript. Holy shit. Oh my god. Whoa. Whoa. It's just so funny. It's like, yeah, JavaScript is pretty easy language. Do you think why it's so popular? Alright. So what we were doing? Neo Cromer, did you just join? Did you just join? Yes, welcome to the stream. Welcome to the stream. No, the answer is no, it's not a bait. This is JavaScript. This is literally JavaScript, seriously. Like, you see, I have a function, and this is JavaScript. Crazy, right? Did you know that I program in JavaScript? Are you joking right now, Neo Cromer? Like, you joking, or you just listened everything I said before, and you're just trying to? Okay, I see. Did you learn coding on school or by yourself? In a boot camp. I learned it in a boot camp. All right. I'm sorry. Okay, so what do we have? Oh, would you look at that? Would you look at that? We have something here. We have something here. Kind of works. Oh yeah, it's actually kind of strange. I have to do it like this, so it has to add y in here, and it will. Yeah, there we go. Look at that. Look at that. Isn't that amazing? I think it's goddamn fucking amazing, mate. So maybe I need to replace this entire thing with position. Let's call it position, maybe just pause, right? And instead of scale, I think we're gonna introduce something like vec2 size. Right. So now we have size, and instead of doing this kind of thing, maybe I'm gonna do it like that. So it's gonna be like this, and I'm just gonna do size X, and this one is gonna be Y, right? This one is gonna be a Y. So then I can specify the size however I want. So yeah, so now this is a size, and then I take this size thingy and I specify it like let's do 100 by 100, right? 100 by 100. Uniform, okay, so it's a wrong one. I have to specify it like this. Okay, and so this is a pose now, right? So there's no offset, there is a pose. Maybe is it position? I forgot what I called it. So I called it pose. So everything should be all right. But it's not all right. So if I change it to, well, it still complains about something. Yeah, it doesn't work. Doesn't work at all. Don't understand why though. It's kind of weird. Position X. What am I missing? What am I missing? What am I missing? I don't know. I don't know what I'm missing. Did it optimize something away? So, oh yeah, I forgot to. This is by the way why I wanted to write a code that automatically analyzes the source code of the shader and extracts all of the uniforms and shit like that. That would be actually kind of epic, but unfortunately, yeah, there we go. So, and here's the thing: we need to now organize the event loop, right, for all of that shite. Organize the event loop for all of that shite. By the way, should I? Probably not. Yeah. So we prepare everything and we draw the scene and yeah. So I'm gonna go to my old code, WE. So here is the event loop, right? So window request animation frame. Aha. All right. So we need to prepare the start. We need to prepare the start. So this is how it's gonna go. It's gonna be start. It's not gonna be defined. Then it's function step, which accepts the timestamp. Right, and we are requesting window request animation frame step. Right, so so and at the end, so we also do the following thing where we just if start undefined. Right, so we set the start to be the timestamp. Right, and then we have a delta time, which is basically start minus timestamp, start minus timestamp, and we need to convert that to seconds because this entire thing is in milliseconds, so we want that to be in seconds to be able to do animations properly. Right, and then we just do start equal timestamp, and then we do window request animation frame on step, and everything looks okay, and we can do all of that shit in here now. So we have a buffer, so I'm thinking that I'm gonna actually initialize the buffer somewhere here, and we're gonna try to draw the scene in the loop, and we'll see how it goes. We'll see how it goes. All right, so I think now it's doing that in a loop, which is kind of cool. So let me pause everything so it doesn't consume too many resources. And let's try to move the position of the player, not the player, but the object over time. So where are we gonna store this entire position? So let me introduce something like let x equal 0, let y equal 0. So we're also gonna have dx maybe equal to 100, and then we're gonna have dy. All right, we have dy, and this is basically what we're gonna set here on each iteration. So let me now, like every time you're about to draw everything, so that's what we do. We set position to be x, and y, and we also want to update x and y, so it's going to be x dx multiplied by dt, and we also replace it with dy. We'll also replace it with dy, and there you go. So that should make this entire thing move in an opposite direction. That was interesting. So let's actually make it move like somewhere here. How about that? So now it's moving here. So, and essentially we do all of that from within the shader. So yeah. Step is like one frame. I guess. Yes, it's one frame.
Keep up the experiments. I have learned so much from watching your streams while working in my boring JavaScript job. Greetings from Europe.
Thank you so much for 100 euros, but I think it's too much. Thank you. I'll probably refund it. Thank you so much. I'm really glad that you're enjoying the stream, but it's just too much money. All right. So yeah. Okay. Let me see. So we're moving this thing around. And also, I would really appreciate if people use donation to ask questions. Seriously, like I really appreciate all of these donations and stuff like that. But it would be better if people, like, if you have a question and you want like unironic, non-sarcastic answer from me, you can donate that question, and I will do my best to answer that question. Well, as like I will do as much as you as I actually donated. That would be like actually preferred way of doing donations. Seriously. But nobody's using donations like that. But thank you so much for that. But this amount of money is just too much for me, and definitely I'm refunding it after the stream. I would probably refund it right now, but I just don't have an access to PayPal from this particular account, so I'll have to do that after the stream. All right. So yeah. So let's continue. Okay, so let's actually do the DVD demo, right? So basically make it bounce around. And after that, we can try to bind textures and whatnot. We can try to bind textures. So, all right, so we need to do the... we need to know the size. So the size of the screen and the size of everything else. So this is that, and we can do something like const width is going to be 100, and this is going to be height. Alright, so, and I'm going to move this entire thing maybe somewhere here. So it's going to be width, height. Alright, so now we need to do this logic where we check whether this entire thing is like actually makes sense. If x is less than 0, or x plus width is greater than 800, but we will probably have to extract that at some point. We'll have to do dx minus dx, right? So this is basically what we do. I think that's how we can achieve that. All right, so, and initial position, I'm gonna put it around like 10. I'm gonna put it around 10. Y is gonna be y, height 600 is going to be dy, dx. Okay, so let's see if it's going to actually do something. And it's working, I think. So yeah, so we're using shaders to draw these particular things. I wonder if I can actually make more of these things. Probably not. Can we leave a trail? Yeah, with shaders, we can do interesting things depending on the position and the previous position and whatnot. Alright, so what we can do. We can keep track of the previous position, right? And that would probably give us some sort of like a direction, whatnot. I don't know how to make it interesting. So if you're gonna have a trail, by the way, so the easiest interesting thing to do is to blur the edges, probably. So that's one thing you can do, right? For example, if you're outside, so this is where we check if the point is inside of a particular rectangle, right? So, but if it's outside of the particular rectangle, we can measure how much it's outside, how much it's from the edge, and basically modify the color based on that distance, right? And I think that could be interesting. I think that could be interesting. So, yeah. Very simple. Zuzin, just refactor your entire pipeline to make this simple trick. Okay, so what I want to do, I want to make a small break because I need to pee. Zuzin, it's easy. Just refactor your entire fucking shader pipeline. It's that easy. Alright, small break, 3 minutes. Right, so let's make a small break and you guys have fun. Yo, what's up? Okay, so I want to make the edges blurry. I want to make the edges blurry. So I want to have a function that checks whether a particular point is in a rectangle, right? So rect contains point, right? So here we can provide the point itself. Then we can provide rect position and rect size, right? Rect size. And then we can literally put this entire condition there. So this is what I want to do. So to simplify it mentally for me. Oh, it even aligns perfectly. Nice. I really like that. So this one is rect pose now. I can probably do something like this. Rect pose. So this is a rect size. Rect size, and P is now point, right? Point. There we go. So and then we can do something like rect contains point and GL frag coordinates xy size and pose. Actually, pose and size, right? Pose and size, and I can remove this entire thing. There we go. So it's a little bit easier to comprehend now, hopefully. Next thing, how can we check how much it is from the edge? So we can try to basically, we know that here, if we are here, we are essentially outside of the rectangle, right? We're essentially outside of the rectangle. What we can do now is calculate how much we are outside of the rectangle. So we take GL frag chord x, right? We take x and we subtract from I guess pose x, and that gives us the first distance, right? It gives us the first distance. The second distance that we probably want to do is going to be pose plus size x, right? So this is the distance from the left edge, and this is the distance from the right edge. And the thing we want to do, we want to actually grab the minimal one, right? So we only care about the minimal one. Because if it's closer to the left edge, that means the distance to the right one is going to be bigger than the one to the left one, right? So that does make sense. So, and yeah, now we have the minimal one, and now we need to know the thickness of the blur of the edges that we want to have. So what's going to be the thickness? We can probably define it somewhere here. Right, it's going to be something like this. So blur edge thickness, right? And how many pixels do we want? Let's actually say that it's going to be 10 pixels, right? So it's going to be around 10 pixels. Okay, so let me assign that to some sort of a variable. So maybe it's going to be something like float edge x. Let's call it edge x. So because I want to also repeat this entire stuff for y, right? So let's actually try to repeat that for y as well. But I'm just thinking what's going to be the better way to do that. Probably just duplicate. So we have edge x and we have edge y. So it's going to be position x, position y, position y, position y, position y. And we can probably even make another interesting thing. We can try to find the minimum between x and y, right? We can try to find the minimum between x and y. So let's literally call it edge, right? Edge. So this is going to be minimum between two minimums of different coordinates. So we sort of unify this entire stuff. I think that should make sense, right? Hopefully. So that's a very interesting way of doing that, but okay, why not? All right. So, and then we know that edge, and I want to do like a, not a lerp. How do you do inversed lerp in GLSL? GLSL inversed lerp, right? Inversed lerp. What's the common name for inverse lerp in a function in GLSL? Smooth steps, which works like lerp, which works like your inverse lerp function combined with hermit smoothing and a clump. Maybe we can use smooth step, why not? I want it inverse lerp, but maybe smooth step is gonna be better. So perform, yeah, I guess interpolate, yeah, hermit interpolation between two values. All right, so, and what values are we trying to do here? So essentially, if I were to do inverse lerp, right, so I would like to have a value from 0 to blur edge thickness, right, blur edge thickness, inverse lerp, right, from 0 to that, and I would provide the edge, and it should return me a value from 0 to 1. This is what I want, right? So what's the easiest way for me to do that in GLSL, in smooth step specifically? I think I just do it like that. I just use smooth step. Do I? I think. Yeah. Okay. Smooth step. I wasn't sure if it will work. All right. Nice. And the thing we can do now, we can multiply the color. We can. Oh yeah. Now we can mix the colors. So yeah. Now we need to do GLSL. Mix. So I think mix works with the colors, right? Specify the start range to which yeah, nice. Let me think. So let me think. So I need to define these colors here. So let's define it like that. Background color. Kalum 99 version 2. Thank you so much for Twitch Prime subscription. Thank you. And welcome to our epic smooth step club. How about that? Hello. Foreground color. So foreground color is going to be that one. So I just want to have these things as macros. So that means it's going to be background color, and this one is going to be foreground color. And essentially I want to do interpolation from background color to foreground color with this smooth step. Yep. And let's see how it's gonna go. Yep. So that's gonna be cool, I think. Alright, I think I did a fucky-wacky somewhere, so I already closed everything. I forgot my sponsors many months ago when I'm making an old email. Okay, sure, fair enough. So this is a name generator. Chromium index HTML. Okay, nice. That's really weird. Huh. It does kind of do that, but at the same time, I think I fucked up something pretty badly. All right. So we know that this thing. Wait a second. I have to do absolute value of this stuff. Yes, I need to do the absolute value. I just realized that. So this is going to be the absolute. Yeah. All right. Can I do it like that? So this is another absolute value. And another absolute value. Okay. Oh, that is cool. Wait, that's so cool. God damn. Holy shit. Shaders. This is basically a mistake in a shader, how it looks like. Computer graphic is so cool that even mistakes look cool. Yeah. So here's y, distance between y, and position y, distance between y. I'm pretty sure I'm doing something incorrectly here. Like, because this is, so contains point, right? So point, so rect position, position size makes sense. Rect position, point x, point y, point y. So I'm using the, oh yeah, if it contains, it has to be foreground first of all. If it doesn't contain, maybe we have to invert this entire thing. Probably not. Yeah, probably not. It probably goes way outside, so maybe edge, the smoothest step, the edge itself shouldn't be bigger. So if edge is less or less than blur thickness, that we're gonna try to do that. Otherwise, it's straight up gonna be foreground. So I'm pretty sure I'm making a mistake somewhere, but gel frag color, background color. Okay, so that's cool. That's cool. I think I'm understanding smooth step incorrectly. Maybe it has to be, yeah, maybe it has to be from foreground to background. That's what it feels like. I think that's the interpolation we have to go for. I'm pretty sure. Yeah, that's pretty close. But at the same time, on, like, in these places, is just, yeah, it just doesn't work. Yeah, so it basically does exactly what I ask it to do, because there is a mistake in my logic. But cool thing is that now I can make the edge thicker, and this is how it's gonna look like. And it computes very, very, very fast, right? So shaders allow you to do this kind of effects and stuff like that. So that's pretty cool. You can make the thickness even bigger now, and yeah, it's very blurry now. It's very blurry. So pipes, yeah, that's probably what it is. So I guess, yeah, because on this, how can we? So if one of the edges is too big, we could probably use the radius, right? If you're bigger than a particular radius, so that means you can interpolate or something, but yeah. Interesting. If we make the edge 0, how it's gonna look like? It's gonna look like a regular, yeah, it's gonna look like a regular thing. It's gonna look like a regular thing. So what would be the best way to do that? Let me draw a little bit. Let me draw a little bit. So this is gonna be my paint. Okay, so essentially, if you have the point here, the distance to this edge is super small, but distance to this edge is super big. So that's why this distance is always chosen, and that's why we have this like trails going off of the corners. So what I need to do, I need to like find the actual distance here, but what kind of distance I'm looking for? What's the easiest way to do that? What's the easiest way to do that? We probably need to check things properly. So basically, if Yeah. So we need to think in terms of these ranges, right? If x is within the range, but y is not, right? Maybe we should use y then. That's a very interesting way to think about it. Essentially, right? If this thing happened, we probably have to use y. We probably have to use y. And edge equal to that. Yeah. So if it's within the x, we probably shouldn't use x. No, it's not how it works. It's not how it works. What's the easiest? For some reason I cannot do such a simple thing. With a circle it would be way easier, by the way. With a circle, right? If you had a circle, basically you would use radius. But yeah. And what's fun is that you can just use different ways of measuring all of that. But what essentially I want to be able to do. Why is it so hard for me to wrap my head around it? Maybe I shouldn't try to do that with the square, but... So, if one of these things is too big... What if I have to get the max... That's a very interesting idea. What if I get the maximum between them instead? That's a very interesting idea. Okay. Alright, so... And thickness is gonna be 100. Alright, not bad. So that's already more interesting. Alright, let's actually go with that. Now, so as you can see, our thickness is hard-coded. What if we unhard-code it? So we're gonna have, well, we can, to make it more interesting, let's actually make it like one, well, it's actually on the corners. Why is it on the corners though? And it's stuck for a second. So let me think. Somebody already was spoiling something in the chat. I'm trying not to read the chat. Can somebody please ban this person so I don't read their message? Because it's a spoiler. So I need to decide what exactly I want to do from this thing. Right, so what I have from this thing. Right, so what if we have a center? Let's actually think about the center, right? So in terms of the center, this is kind of not exactly what I want, but we can think about it in terms of like a circle, which is a kind of dumb way to do that, right? So, but we can think about it in terms of a circle and the, yeah, but I don't like that. I don't like this approach. Okay, let's think about it in terms of a circle. So it's gonna be something like that. I don't like the circle idea, but yeah. And because we're talking about the square, but alright. Why sometimes I just get such a huge brain fart on such a simple things is just incredible. I don't know why. Okay. But to be fair, like here we know that we're outside, so maybe it makes sense. Yeah, maybe it makes sense to do it like that. But it's gonna look very circly. That's the problem. It's gonna look very circly. So GL frag coordinate, right? GL frag coordinate xy, and I subtract the center of the rectangle. The center of the rectangle is basically the position plus size, like half of a size, right? Plus half of a size. So this is the center, right? And yeah, and then I need to take the length of this entire stuff, right? Take the length of this entire stuff, and probably, and now what do I subtract? I probably subtract that width and height something, but maybe not. It actually ruins everything. Probably subtract like minus width, right? So since width and height are the same shit, and it doesn't work. I'm so demotivated. Holy shit! I'm so demotivated. Okay, width is not that. All right. Size x. Okay, yeah. I just turned it into a circle. So we have two situations essentially. We have two situations, which is kind of dumb. We have to have like a lot of corner cases too. Why such a simple thing is so much goddamn fucking effort? Holy fuck. Excuse me. All right, if we are within this range, right? So we just have to find this distance, like basically the minimum between that and that, right? And doesn't matter where the point is, so it's somewhere here. So that's the first case. The second case is that one, right? So that makes sense. So it's kind of like a similar case here, right? Another thing we can do, we can just basically don't give a shit about the corners, but they're gonna look shitty. But the problem is that for the corners, we have to have 4 different situations and use the radius. So basically we're gonna round them up like that. And I'm thinking, is there any way to not have 4 different cases for the corners? Is there any way to not have that? Because basically you have to do this kind of shit around. Well, you can basically compute the distance to each individual corner and just pick the smallest one then, I suppose. Because the problem is that I don't want to do too many corner cases. Okay, so I'm okay with 2 corner cases for horizontal and for the vertical one, but 4 more, no. I think for the corners we can have the third one, so we can have 3 corner cases. Let's give it a try. So initially edge, let's say edge is going to be initially 0, right? And here is the first corner case. The first corner case when you are within this thing, right? You are within this thing, and I copy pasted a lot of spaces. I don't want to see that. All right. So, and in this particular case, edge is essentially this thing. Holy shit. Okay, is this thing. Well, I think I deleted all of this. Okay, so let me remove all of that. So we need to take the absolute distance between point X and GL frag chord X, and actually minimum between those things. So it's going to be absolute point X minus GL frag coordinate X. Am I doing that correctly? GL frag. Somebody's spoiling shit again. Ban them! Fucking ban all of the spoiler people. Seriously, mods, fucking ban them. Holy shit. Just there's so many people who want to ruin fun for everyone. Okay. Frag chord. Ban all of them. Permaban. Okay. So. what mods you unmodded everyone? Wow, do I have to explain the joke? Nice. All right, so it's almost like it's the point of the joke. All right. So, and I can probably duplicate this entire stuff. So this one is going to be this. It's going to be Y. Okay, so in this particular situation, what do we need to do? We need to like literally 4 points. Okay, so let's not do corners. Let's not do corners because they're too cancerous to do. All right, and something went wrong. Okay, so oh shit, undeclared identifier rex. Fuck. All right, let's do it like this maybe. So this one is gonna be just a pose. So this is gonna be like this. So maybe I can actually, yeah, I can select shit like that. That was interesting. So I think I'm gonna at some point, Site is pretty cool, but I'm having problems with it. All right, 23. Point undeclared. Okay, so this is because this is not the point. I see. My brain just hurts. Oh fuck. Oh fuck. So the point in this particular case is gonna be yeah, okay. So let's do it this way. XY. So this is the point that we're talking about. So this is going to be point, and this is has to be position. Okay, so that's already better, but I don't know where exactly I forgot the semicolon. Where did I forget the semicolon? So it says something about const into hive 27. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I see, fucking finally. Holy shit. Syntax error. Huh? Syntax error. Fucking thank you so much. Syntax error. What did I do? What did I do? Syntax error. This is so helpful. Thank you so much. Minimum. Oh, I see. Thank you. Holy shit, this is so bad. Fucking classic. Like, haven't we learned anything from programming language development that this is a bad idea to report errors like that? When people fucking learn to not report syntactic errors like that, when do they fucking learn? Who the fuck does that? Oh my god, like it's just... Okay, so in case of that one, right, I want to actually set the edge bigger than blur edge thickness, so it's actually plus 10. Okay, and it still provides, oh my god, okay. Excuse me, why does it still do that? Excuse me? So if it's within that, we take the minimum. I'm so confused, actually. Like, why does it still have this... Oh my god, I'm so tired with this square thing. So, okay, if we on the X... Oh, it's the opposite thing. If we on the X, we have to do Y. I see. I see it now. It's really draining. Like, it's draining a lot of energy having to deal with this kind of shit. Thank you! Fucking thank you. Alright. Whew, that was hard. Okay, so if I make the thickness like this, yes, that's what I want to see. That's roughly what I want to see, but we don't handle the corners, right? We don't handle the corners. So, holy fuck, apparently, why making the square blurry is such a difficult task? Holy shit. Who designed geometry? Who designed geometry? Whoever designed geometry is banned. Okay. So now to handle the corners, we have to have 4 different points, right? So corners. Alright, so what we're gonna have here. The first one is, I guess it's the point, right? So this is gonna be point. The next one is gonna be point plus vector plus size multiplied by vector 2, 1, 0, like that. Another one is gonna be like that, and another one is gonna be, well, you know what, I have an idea. What if we actually make it like this? That's a pretty good way to actually go through all the corners. Look at that. These are all the corners. So after that, well, what am I doing here actually? So this is not JavaScript, this is shaders. I wonder if I can have this. Please don't tell me I cannot have arrays. Please don't tell me I can't have arrays. I want to have an array. Don't tell me I cannot have arrays. Okay, I can't have arrays. GLSL arrays. I want to have arrays. GLSL array. Fucking Google. Okay. Okay, so maybe you cannot initialize them like that. Let me try to do it like this then. So where do we have this shit? Oh, okay. That's cool. So I can initialize them like this then. So I'm gonna do a pretty interesting trick. I'm gonna iterate from I to 4, like this. Alright. And corners I is gonna be essentially point plus size multiplied by vector 2 I mod 2. We can actually use mod 2 But all of that has to be converted to float, right? So we need to convert it to a float. Or float I divided by 2. So essentially we are generating binary code, and we're using binary codes to multiply size either by 0 or by 1, generating different possible corners. So by doing that, we're iterating each individual corner of this rectangle. And what's interesting is that we probably don't need corners at all now, because I can now take the, so this is the corner, and I can probably compute the distance between that and the current point. So essentially I take this entire thing, right, as the corner. So maybe it will make sense to assign it to a corner. Vec2 corner, right there, like this. And then I do what? I take my point and subtract corner, and I take the length of this entire stuff. And then I know that edge is 0, so edge should be probably very huge. Edge should be equal to blur edge thingy. And essentially what I do edge minimum between current edge and that. Holy shit, I did it. I came up with a pretty 5-head way of iterating through all the corners. So this is how I iterate corners. Holy shit. Holy shit. That's a very interesting way of calculating. Do you guys understand how I iterate corners of the rectangle? So from 0 to 4, I'm using index of the corner to calculate position of the corner in space. So this is how I map the index of the corner to the position of the corner in space. So that's a pretty cool way to do that. It's almost like a gray code trick, but we don't have to do that in a gray code order. So I wonder if it's gonna work now. And it didn't work. Module separator supported in JS and above only. Ah. Okay, so instead of mod, what we can do? Can I do this thing? So should be able to do that. Are you fucking serious? Okay, can I set the version of it to... Okay. Holy shit. Okay, version... can I do it like that? Invalid version directive. 150. Could not compile client version number not supported. Yeah, 300 yes, yeah, 300 yes, and it probably will require must occur in the first line of the shader. Holy shit, okay. Why don't I have module operator though? 130. Oh, okay. That's a good point. Okay, let's try to think how. Okay, so I definitely can divide it by 2, right? I can definitely divide it by 2, but I cannot mod it. I cannot mod it. Where is my T? Okay. So bitwise operators. Operations. How do I perform bit operations in GLSL? GLSL 113. Okay, they have introduction. Okay, GLSL. So also, I just realized that I think I probably have to put that in both of them, right? So I have to put them in both of them. Let me see if it's gonna work. Did I already close it? No, I didn't close it. Okay, could not compile, not supported. Why would it not be supported? Okay, so I remember that. So where am I? Okay. The fuck? I didn't want to do that. In the thing. So we had something like array leap probe, right? Array leap probe. I don't remember where it was. Was it array leap probe or was it not? Okay, so I don't remember that I had this thing on the GitHub. I remember I had it on the GitHub. So this worked, but it probably used a different initialization method. It probably used a different initialization method. So I already tried that, or didn't I? I don't remember if I tried that. Yeah. Invalid version directive. Yeah. It's really strange. So GLSL version directive. Oh, by the way, something dumb as like 100. Would something as dumb as 100 even work? Yeah, it does work. It does work. This is really so. By the way, so in my OpenGL template, we use that one. Okay, I'm done with that. So let's try to come up with something else. So one way to do that is to actually inline this corner like this, right? Just inline it like this and actually do it like that. Okay. So, and we're gonna simply duplicate it with this amount of times. So it's gonna be 1, 1, 1, 1. There we go. Yes, that's how we're gonna do that. Because modern APIs are shit, and that's why I'm doing it like that. Fuck graphics API. So yeah, so these are different corners, and we calculate the distance between them, and we're just grabbing the minimum between them. And all right, so 32 semicolon. I put a semicolon somewhere probably because I forgot to do this thing. And there we go. Perfect. So this is exactly how I wanted it to be. This is exactly how I wanted it to be. That's kind of cool. And I can even update the blurriness, and the bigger the blurriness, the bigger it's gonna be. I just didn't expect that this is the amount of code you need for a square to work properly. It's just insane. Like, I guess like Square does introduce like corner cases. They're not called corner cases for nothing, right? So that's why they're called corner cases. All right, so now here's an interesting thing. This thing is hard-coded. What if we unhard-code it and make it a uniform? So this is basically what I want to do. So it's going to be uniform, floor, let's call it blur, right? And essentially, let's try to animate that blurriness. So every time you hit the corner, we're gonna set the blurriness to a particular value and then reduce it. So every time it hits the edges, it will become blurry for like a moment and then go back. It's like, you know? So I think it's gonna be cool if we manage to do that, of course. So we're gonna replace this thing to... oh, that's very interesting. Cool. Let's call it blur in here. Right, so this is a blur. And let's now set that to a uniform, right? So it's going to be something like blur, the main program. And how are we going to do that? So what's interesting is that maybe I want the blur to be a value from 0 to 1, because it will make it easier to animate, right? So essentially how we're going to do that is going to be defined blur so this is a blur. So blur edge. So I think this is how we're gonna do it. So blur, how did I call it before? Define blur edge. So yeah, essentially now we just need to multiply this by blur edge every time we refer to a blur, right? Blur edge. All right, so it's kind of a strange way of doing that, but I think that's okay. All right, so let me see. Okay, so we're gonna set the blur, right? We're gonna set the blur to something. Uniform 1f main program uniforms blur 1. So yeah, okay, so this seems to be working as usual. So I didn't break anything, right? I didn't break anything. That looks cool. So now what I'm gonna do, I need to actually set the blur to something. So blur is gonna be initially 0, right? So, and we're gonna be setting the blur on each iteration. Blur is gonna be blur. Okay, so there's no blur now. So this is what I'm talking about. Every time we hit the edge, we're setting the blur to 1. Every time. That's very important. Why did you switch to... it's because I couldn't set up the dark one. Yeah, pretty much. Well, I mean, it takes too much time to set up and I cannot make a content out of it, so that's why I decided to switch temporarily to that until I figure out how to make a dark thing. Alright, so let me see. Now every time we update everything, right, so we can do something like this. It's going to blur minus dt. Maybe it's gonna be something like this: blur minus dt, and we're gonna take a maximum between 0 and that thing, right? And oh, that's very interesting. That's funny. It's initially 0. It goes to negative. It goes to negative. And then I take a maximum between them. It should be 0 again. So I'm not quite sure what the hell is going on, but okay. So it should become blurry once I hit the corner. Yeah, there we go. So, all right. And then I do blur minus dt, right? I do minus dt, and if it becomes negative, it, excuse me. Why is it growing? Because it's a start. All right, that's very cool. And now, on top of that, we can actually multiply that by, let's take 2 maybe. Yeah, maybe even 4. Is it too fast? It could be actually too fast. What about 8? Probably because the value itself is too big. What if it's going to be 50? So it gives us this pulse. Okay, that's cool. And maybe the speed of this entire thing should be also bigger. So what's the speed? What's the initial speed? It's let's make it around like 200. So that's cool. And that is done with shaders, by the way. That's cool. Yes. So this is exactly what I want to do, right? So we have a raid from Esther. Hello, welcome to the stream. We're doing a Webgl. So yeah, so essentially, yeah, it's kind of dumb, but every time the square hits the edges, it becomes blurry, and the blurriness is done in shaders. Right, so it's a shader that actually makes this thing blurry every time you hit it. To add screen shake on a rectangle impact, probably, but there's not that many points of references for that to make sense. How was your stream, Esther, by the way? How do you feel, by the way? Because yeah, I hope you're already better. Doing the DVD menu thing, yeah, it's the easiest thing to do, and sometimes it just gets stuck because it's too fast. Right, but yeah, that's cool. So I think it probably makes sense for me to finally upload that somewhere. All right, so let me see. So it's gonna be something like new. Okay, so it's gonna be readme md, and it's gonna be d7. All right, quick start. Console. I explore xz index html. So that's pretty much it. So that's the whole thing. Maybe I also need to introduce the license. So let me save that. License. All of that is going to be released under MIT license. Oh my god, so. Alright, so it's gonna be 2021. Copyright holder is Alexei Demov. Gmail.com. Okay, so that's pretty much it. That's pretty much it. And the font is a Victor Mono, as far as I know. This one. Victor Monov. That's the name of Russian font. Okay, I'm sorry. It's not really Russian. That's pretty cool. It was suggested by Anabot. And I'm just using it. It also has ligatures and stuff. Okay, so what am I doing here? I'm gonna initialize everything, right? And I'm gonna add everything here. I'm gonna commit ready, set, a go, and it's gonna be like that. I like ligatures. Yeah, they're not bad. B7. Okay, just playground project to learn Webgl. So that's basically what we have here. I'm gonna create the repo. I'm gonna create the repo and git remote add origin. Right, and I'm gonna push all of that right into the repo. Origin master. Git push origin master. And there we go. If anyone is interested, you can find the source code here. And maybe I need to add this to the description as well, to the README. I think so. You just open index.html in your favorite browser, and it should work. So it will pick up the index.js and just start doing the OpenGL thingy. Hopefully, I don't know. We'll see how it goes. So I'm not doing any, you know, how is that called? Translation to for all the versions of the browser. So you need the latest browser for it to work, I suppose. All right. So what I wanted to do, I wanted something. Yeah, I wanted to do a CSITE README, and I wanted to add the description here. Yeah, so just a playground project to learn Webgl, and we can maybe give a link to Webgl. He wrote the README for Putin. Yes. Does Internet Explorer support Webgl? Probably not. So basically, it's a my inside joke. Like every time in instructions, if I want to say in instructions that just open that file in a browser, I use this command. Because how should I do that? Should I do Chrome or Firefox or XDG open? What do I have to put there to actually make it clear that you have to open it in the browser? And at the same time, everyone has an opinion on what browser you should use, so you don't want to like pick the sides and stuff like that. So I just put iExplorer, right? And people who understand, you know, web development and web generally, they would understand the joke. So, and this way I don't just sort of don't pick the side and stuff like that. If you're using a Vertex, you know that. Double click index.html. Yeah. Okay, Webgl. Do we have a link to a Webgl, to official site of Webgl? Does Webgl even has an official website? I guess Cronus. Wait, is Cronus responsible for Webgl? Oh, I didn't know that. I thought it's W3C who was responsible for it, but maybe it's a collaboration between them. Who knows? Maybe it's a collaboration. The collaboration everyone waited for. Am I right? All right. Yes. All right. Cronus is responsible for everything. I see. Add readme and commit. Add description. Add project description to readme. I'm gonna push that right into the repo. I'm already streaming for 4 hours. Oh my god. I wasted so much time, but I've done so little. I guess that's the result of today's stream. I guess like every time you do like OpenGL, you're just doomed to waste a lot of time. But that's what we managed to do today. And that's a pretty good achievement. I learned how to blur squares in generally in shaders. It was actually kind of interesting. But unfortunately, boys and girls, it is time for me to go. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all tomorrow. Tomorrow, according to the schedule, we're going to be doing a game development in C++. Check out our schedule page for more information on different projects we're working on. Check out our VODs channel, where I upload all of the stream recordings. This stream is going to be there, but tomorrow. And also check out our Discord server for offline discussion with the community. And let's maybe rate somebody. Is anyone streaming anything interesting on Science in Technology section of Twitch today? Let me see. So let's wait for a minute for Twitch to load up, because apparently rendering a React DOM is unsolved computer science problem. In P-complete 1. Let me take a look at the section. Right. So game dev. Oh my god, I'm scrolling, it stopped scrolling. Holy shit, it's so bad. This website is so bad. Entity frameworks. Christian Parpat, we haven't read them for a while, so maybe let's just read them, I suppose. I don't know, I didn't see anyone else to rate today. Alright. Get ready for the raid, boys and girls. Get ready for the raid. And I see you all tomorrow. Love you. Mwah.